Welcome to this new one-shot video of indefinite integrals. This video took tremendous amount of effort to build up. That is the reason it took so much of time to get released. In this video, we are going to systematically start with weightage of the topics in JEE Mains, and then we are going to systematically move towards the syllabus comparison from 23, 24, 25. Then we are going to see what are the exact details of the syllabus using a mind map, and then we'll go into 28 problem type categories in which I have classified all the last 5 to 10 years of questions that came in JEE. So without any further delay, let us start. But before starting, you should understand that this video has a do and a don't. The do is, when you're watching this video, it is very important that you do not watch it like a movie. Keep taking notes, keep solving questions by pausing the video and work along with it. The don't is that this video is not meant for a person who has not started or just started indefinite integrals. This is meant for a person who has already completed it. That would mean we will not go into the basics, but we will go into problem types. Wherever required, important facts I will revise and I will keep telling you. But largely, you will enjoy this video more if once you have completed your basics of JEE syllabus. So without any further ado, let us start with it. If I talk about weightage of indefinite integrals in JEE Mains, you will usually get a question from this topic. Actually, we should understand the syllabus more or weightage more in terms of integral calculus. Integral calculation will have 5 questions from it. Largely 1 and 2 questions will come from area and differential equations. And then 3 questions will come from indefinite and definite. Usually students think that from indefinite not many questions are asked, but the reality is that those questions get asked in definite integrals. So definite integrals, they will ask questions in which you have just limits over that indefinite question. And you will have to use the same technique as you solve an indefinite integral question. So let us understand that the integration part will have 3 questions as weightage, and this is the part of that larger integration chapter. If I look into the syllabus comparison from 23 to 24, what you can see here is from 23-24 there has been no change in the syllabus. The syllabus has remained exactly same, and so in 25. If I look into mind map, that is much more interesting enough. In mind map, you can see that we'll start with the meaning of indefinite integration. Then we move towards technique of splitting an indefinite integral into 2 such integral which are in standard forms and can be integrated to get an answer. When we move towards the idea of substitution, and we look into standard substitution, and then using that we find 1 by quadratic and 1 by root of quadratic kind of questions. Then we move towards the by parts, and in by parts we start with the idea of questions based on Eilert rule, invisible second term, regeneration, important formulas, reduction formula. And ultimately we move towards questions based on partial fraction, where we solve 5 problem types. And then we slowly move towards trigonometry, where we solve 9 problem types. Then we move towards rational functions, then where we solve 3 problem types. And in irrational function, we take care of 5 problem types. In this manner, from JEE Mains point of view, and like in the standard note, there are 35 problem types. But usually what I have seen in JEE Mains, more than 20 have not been asked. And I presume that there are 8 problem types that can be asked. So that 8 also I have included in the process of making this one-shot video. So this is an exhaustive video. After watching this video, I don't think you will require any more problem types to solve problems based on indefinite integrals. Largely, in order to understand this chapter, it is a very good idea to understand in terms of algebra of integrals. Yes, there is nothing like algebra of integrals. We have learned algebra of differentiation. So in order to compensate that, integrals have come up with some techniques. So what I am trying to tell you is, like when we have sum of 2 integrals or sum of 2 functions, in case of differentiation, we can distribute that over it. So if you have x plus sin x, you can differentiate x and then you can add and differentiate the sin x part. But in this case also, if you have x and sin x, we can still distribute the integral sign over it. The second is basically if you have been given a composite function. Now in case of differentiation, for composite function, you have something known as chain rule. Instead of chain rule, what we are using here is a technique of substitution. For functions into multiplication, you have a product rule in differentiation. Instead of product rule, what we have here is nothing but the by parts. And for division of functions, what we have is a quotient rule, but instead of quotient rule, what we have is partial fractions here. So you can see that we are doing exactly the same thing, but instead of using algebra, we are using these 3 very important techniques. In fact, these 4 very important techniques. Now what we will do is, you will see that every question when we are solving, either we are going to split it into two known integrals, either we are going to apply some kind of substitution, or we will apply by parts or partial fraction to solve the question. So inherently in this chapter, there are only these 4 techniques that needs to be applied while solving a question. Now let us move into the first idea, that is algebra of integrals, and where we will use the idea of splitting an integral into two integrals in the form of addition and subtraction of two integrals, and we'll solve the question. This is the first important idea. So idea is to take an integral and split it into two standard integrals, apply the formula and get the answer. Now I am not taking some specific problem on this idea. The reason is that this idea will be inherent in all the problem types. You will find this idea in all the problem types when you move forward. So this is an underlying theme that will always be there. The next idea is nothing but substitution. Now substitution, we all know it is applicable for composite functions, and there is this process of doing it. So I will not go into the details of it because basics you all know. This is the process that we are going to use. So now there are two things when you are looking into a composite function like this. So there are two ways to look into it. One is either you look for the composite function or you look for the derivative of gx. This is very important, because what happens is the important thing would be to understand whose composite function it is and then put that substitution. So in order to understand what substitution to put, you will have to either look for from where this composite function is getting generated or what is the derivative. So we will observe g dash of x, figure out f of gx, put gx equal to t, differentiate, replace gx by gt and dx by dt by g dash of x. Integration will reduce into some kind of a standard integral. We will apply the formula, we will get the answer. Interesting thing here is don't forget the constant of integration, but in objective it does not matter because they will give you the constant of integration. You don't need to worry about it. Now this is the type 1 question in which we are going to discuss composite functions. Now let us look into this 2024 question. Question says that you have been given an integral that looks like this. We have to integrate and get an answer. So now a very simple thing here to be observed in the first step would be that if I just write it like 6 cosec square x dx divided by 1 minus cot x whole square, then what you can see is basically the cosec square x. So that is what I told you, that whenever you have a composite function f of gx into g dash of x, your substitution will become easy if either you observe this part or this part. Here it is easy to observe cosec square x because cosec square x is related to cot x. The derivative of cot x is nothing but minus cosec square x. So if you are able to observe this in the next step, it would make sense if I substitute cot x as t. Now when we are doing such substitutions, it is very important that to understand that cot x differentiation would be minus cosec square x. But if I take minus also along with it, then it will become cosec square x. Now if I also take 1 along with it, you can see that the whole of these part is getting, denominator is getting covered. And now your integration will become much more simpler. So it is very important that you tag along the constant terms when you are doing the substitution. So if you differentiate this, it comes out to be nothing but plus cosec square x dx. So now you can see that whatever is written here, all of that is getting covered. So in the third part, we are going to resubstitute it. This becomes 6 times dt by t square. And if I integrate, it is minus 6 by t plus c. Constant of integration is important. Now moving to the fourth part where they want us to find the value of constant of integration. They have given us the value of 0. So what they are saying is if you put, and let us resubstitute and then put. So if I write my integral as a function of x, you can see that it becomes minus 6 by 1 minus cot x plus c. Now if I put x equal to 0 here, what is going to happen? See, when you put x equal to 0, your cot x will tend towards infinity. And hence the denominator, this term as a whole will become 0, since denominator is becoming very large. Now once you do this, we can observe that what will happen for I0, this part becomes 0 and this becomes c, and this is given as 3. So the value of c comes out to be 3. So this is what they were trying to give us, the value of c. As a result, in the fifth part, you can observe that you have got your function as nothing but
minus 6 by 1 minus cot x plus 3.
Now see, this is no more a question of integration. The integration part we have done. In the sixth step, they want us to find the value of this function corresponding to pi by 12. See now, if I want to find this value, if I substitute, this pi by 12 value will become minus 6 by 1 minus cot pi by 12 plus 3. Now for finding this value will require cot pi by 12. Pi by 12 in trigonometry is nothing but 15 degree. And you might have definitely done 10-15 degree there. If you don't know it, it is nothing but tan of 45 degree minus 30 degree. You can apply the formula and what you are going to get is root 3 minus 1 by root 3 plus 1. Now we will take this value and find the value of cot 15 degree. You can see that cot 15 degree will become root 3 plus 1 by root 3 minus 1 and substitute this value. So the value of I pi by 12 comes out to be nothing but minus 6 by 1 minus root 3 plus 1 by root 3 minus 1 plus 3, and if you simplify this, this becomes 3 root 3. So you can see that my D option matches. Now in this 2021 question says that you have 2x minus 1 into cos of root of 2x square minus 1 whole square. So what you can see is whatever quantity is written here and whatever is written here, if you simplify, it will become the same quantity. This is important to notice. Why this is important to notice? Because another thing you can notice from here is whatever written inside, the derivative is given here. So in this question, it is critical to understand that in the earlier we were able to understand from g dash of x. Now in this question, we will be able to understand the substitution using f of gx. So this is another variation of the same idea in terms of application. So in the first step, I will put 2x minus 1 whole square plus 5. See, now I can also put this equal to t, but if you put t square, there are special benefits. So this small variation of substitution will help you simplify question. So if you differentiate it, it is going to be 2 into 2 and this will become 2x minus 1. Dx is equal to 2t dt. One of these 2's will get cancelled out. And in the next part, what we are going to do is do substitution. So you can see in the numerator, whatever is there, we will get 1 by 2 out of it. This will become cos of t. Then you will have a t dt. 1 by 2 I have written outside and denominator there is another for t. So this will also get cancelled. So it becomes a very simple integration in the third part. So answer becomes 1 by 2 sin t plus c, and t we already know what it is. So from the options you can directly see that option 1 matches. Now if I look into this 2023 question, it is a good question. Now what happens in such questions is you need to understand that whenever something weird is given in the question, like x by e raised to the power x, put that equal to t. So if you put this x by e raised to the power x is t, we can't directly differentiate it because there is a variable in the power. We'll have to take log on both the sides. So log of x by e raised to the power x will be equal to log of t, and then you can take x common. So this will become x log x minus x log e. This will be equal to ln t, and then you can see that log of e will become 1. So what we have is x ln x minus x is equal to log of t. In the next part, once you figure out the substitution, we will differentiate this. This will become nothing but ln x. The next part will become x into 1 by x. We have applied product rule. Minus 1 is equal to 1 by t dt. Once you have done this, you can see that this part and this one will get cancelled out. We have a dx in multiplication. Let us write it here. So what we have got is nothing but ln x dx is equal to 1 by t dt. This is important. Once you have figured out this, in the third part we are going to substitute and get the answer. Integration is the simpler part in this question. You can do integration very fast. So in the third part, if I substitute the value, what am I getting? This becomes nothing but t square. This will become 1 by t square. ln x dx is already given to us here. This will become 1 by t dt. So integration is the simpler part. Just figuring out the substitution was the important part. So if you now do this, this becomes t dt. This becomes 1 by t cube dt. And fundamentally, finally the answer comes out to be
t square by 2, and this will become minus of t raised to the power minus 2 by minus 2 plus.
This is what we are getting.
And now what they're saying is basically, if I look into the what they have given on the left hand side, right hand side, so what they have given is 1 by alpha t raised to the power beta x minus 1 by gamma t raised to the power minus delta x. This is what is given to you. In fact, let us also remove x, because when we wrote t, it was already there. So if you compare what we have got and what they have given, and if I put them in the same frame and compare, you will be able to get the value of alpha. So alpha comes out to be 2. We can get the value of beta. Beta also comes out to be 2. We will be able to get the value of gamma. You can see that gamma, minus gamma is minus 2 plus here. And you can see that the answer corresponding to this, the delta part, since they have also given us minus delta, and it comes out to be 2. So everything is coming out to be 2. Let us put the value and see what is the value of this expression in the fifth part. So what they are asking is alpha, that is 2, plus 2 times beta, that would be 4, plus 3 times gamma, that will be 6, minus 4 times 2, that is 8. So if I figure out the answer, it comes out to be 4. That is nothing but option D.
If I move towards the last question from this problem type, what you will observe here is, some questions would be easier if I approach them from differentiation. So we are going to use the concept of antiderivative. We are going to differentiate both the sides. If I differentiate both the sides here, what is going to happen? My left hand side will become sine x raised to the power 3 by 2 plus cos x raised to the power 3 by 2 divided by root of sine cube x cos cube x sine x minus theta. And if I differentiate my right hand side, let us see what do we get. So we will get a times differentiation of whatever is inside. Whatever is in the form of root, we will get 1 by 2 times root of cos theta tan x minus sin theta. And whatever is inside, if I differentiate, it will become cos theta into sec square x. If I do it for the other one also, what we are going to get is b would be here. The denominator becomes 2 times root of cos theta. We are applying chain rule to differentiate. Sin theta into cot x. And the differentiation in the numerator becomes sin theta into cosec square x. This is what we are getting. Now once you have got this after differentiation, and now if I simplify and just compare the numerator, I should get my answer. So this was my first step. Let us move towards the next step. So let us simplify the first part separately, second part separately, and then substitute and compare. So if I just look into the first part, what is happening in the denominator? So a by 2 times cos theta is fine. This sec square x is also fine. If I go into the denominator, I can simplify and write this as nothing but cos of theta. Tan theta can be written as nothing but sin x by cos x. And what we have is nothing but sin theta. This is what we have. If I take the LCM, and I will do 2 steps specifically, I will take this sec square x can be written as 1 by cos square x, and I can take this cos square x inside. So what is happening is, this will become cos raised to the power 4x. If you take LCM, you will have a cos x here, and then the remaining thing will become nothing but cos theta sin x minus cos x sin theta. This is everything happening inside the root sign, and you had this cos theta in the numerator. Let us keep it intact. So what is happening, if I simplify, it becomes nothing but a by 2 cos theta. This will remain as one part, and the second part, if you carefully observe, can be written as nothing but cos x raised to the power 3, and this will become nothing but sin of x minus theta. Now this is very important to observe, because we are again going to do the same thing with the second part, and if I do that for the second part, let us see what is that we are getting. Third step, if I do this for the second part, I will apply the same process. So it will become b by 2 times sin theta.
And now if I take the sine square theta inside and do the similar simplification, you will see that this will become sine cube x into sine of x minus theta. Same process we have applied. In the fourth part, let us try and add both of these terms up, because this then we will be able to compare. So if I add both of them up, what you will observe is a by 2 cos theta is fine. In the denominator, what we have is a root of cos x whole cube sine of x minus theta plus b by 2 sine theta by root of sin x का whole cube sin x minus theta. And then again what we can do here is basically take LCM, and if I take LCM, this becomes a by 2 cos theta. Here what we will get is sin x raised to the power 3 by 2, and then b by 2 cos x raised to the power 3 by 2 into sin theta divided by root of sin x whole cube cos x whole cube sin x minus theta. Now observe this term carefully, because now if you observe the question, you can see that the denominator has matched. This what we are writing here and this what we are writing here is the same thing. And if you observe this much part, and the interesting thing would be now numerator would be same. So if I now compare the numerators, you can see that in the numerator part your a by 2 cos theta, and if you observe the numerator part should be equal to 1. So in the next step, what we can observe, this was the fourth step, let us move to the fifth. So what you will be able to observe is a by 2 cos theta, this should be equal to 1. That would mean a is equal to nothing but 2 cos theta. And similarly, b by 2 sin theta should also be equal to 1. That would mean b is nothing but 2 by cos theta and 2 by sin theta. And 2 by sin theta. Now in the question what they are asking is value of a into b. That can easily be figured out. So a into b, if I write, it will become 4 by sin theta cos theta. If I multiply by 2, this will become sin 2 theta in the denominator and be written as 8 cosec 2 theta. You can see that with this option B matches. Now in the type 2 questions, we are going to look into trigonometric substitutions. In trigonometric substitution, what you should observe is, if we have a square plus x square kind of a function, we will put x equal to a tan theta, a cot theta is also possible. A square minus x square, then a sin theta, a cos theta is also possible. X square minus a square, so a sec theta, a cosec theta is also possible. If we have, and these three are important, 4, 5 and 6, because questions are directly based on these ideas sometimes. If you have a minus x by a plus x, a cos 2 theta will work. If you have x minus a by b minus x, you can see the order of x has changed. This can also be in multiplication. Then a cos square theta plus b sin square theta. X by x minus a by x, we can put a sec 2 theta. Now this is less used. 4 and 5 are used more often. Now if I do this substitution in this integrals, that is 1 by quadratic form. You can see that first 3 are 1 by quadratic, next 3 are 1 by root of quadratic. So if I take this same substitutions and put it in this manner, so what will happen is, here in the first part we are putting x equal to a tan theta. We are doing this substitution, integrating and coming with this answer that is given in front of us. So now these are the 6 results. These are very important results. You need to remember them. Important thing to note is, when we are doing 1 by quadratic, so this is 1 by quadratic form. So there is a 1 by a term always present. But when we are doing 1 by root of quadratic, that 1 by a term is not present. This is a special hack that you can remember to remove confusion. Now whenever the quadratic equation is not given in x square plus a square form, you will have to apply perfect square concept, bring it into this form and then integrate. If I look into this 2022 question, the question says that they have given this expression, and now we can recognize the substitution just by looking into this. We need to put x equal to cos 2 theta. This is the substitution we should think about in this question. Now let us start from step 1. If I put x equal to cos 2 theta, then dx will be equal to nothing but minus of 2 times sine 2 theta d theta. And if I do this, this integration becomes 1 by x, that is nothing but cos of 2 theta. This is root of 1 minus cos 2 theta by 1 plus cos 2 theta. This becomes minus I can take outside, 2 sine 2 theta d theta. If I simplify, this becomes minus of 1 by cos 2 theta. This will become root of 2 sine square theta, 2 cos square theta. This is 2, can be written as 2 sine theta cos theta d theta. See, once you have written it like this, in the next step you will be able to figure out things. This will become 1 by cos 2 theta. This is sine theta by cos theta. In cases of indefinite, we will usually not write the modulus sign. Once we have written this, you can see cos theta gets cancelled out. Now, what are we getting in the numerator? So, in the numerator, there is minus 2 and we have 2 sine square theta. And in denominator, what we have is nothing but cos 2 theta. If I simplify this, minus 2 is fine. This can be written as 1 minus cos 2 theta divided by cos 2 theta d theta. So, if I simplify, this becomes 1 by cos 2 theta plus 2 times cos 2 theta by cos 2 theta d theta. And if I simplify, this will become nothing but integration of sec 2 theta. And this will become 2 theta plus. If I integrate this, let us see what do I get. This will become nothing but minus is fine, ln of sec 2 theta plus tan 2 theta, and we will get a 2 in the denominator, that will get cancelled out, and this will become nothing but 2 theta plus c. Once you have got this, if I resubstitute the values, and let us see how it looks like. So this will become 1 by cos, so 1 by cos will become 1 by x. This is sine by cos, so 1 minus x square by x. And this is nothing but cos inverse of x plus c. Now in the third part, if I observe that g of 1, if you put 1 here, you can see that it is clearly coming out to be 0, the first part. So this part that we have figured out is nothing but our gx. In the fourth part, we are going to put the value as 1 by 2. And if I do so, let us see what do we get as a result. So this will become minus of ln 2 plus, this will become 1 by, so this will become nothing but root 3. And this will become pi by 3. So what we are getting is nothing but ln of 1 by root 3 plus 2 plus pi by 3. Now let us check the options and see which option matches. So in the first option, if you simplify this, if you rationalize this, our answer will match. So option A matches. Now in this 2024 question, they have almost given us the substitution on a platter, because they have already given tan inverse of x cube plus 1 by x cube. So we can directly put our substitution in the first step as nothing but x cube plus 1 by x cube is equal to t, is equal to tan theta. If I do this, what is happening? Let us see. So this, if I differentiate, will become 3x square minus 3 by x raised to the power 4. And dx is equal to sec square theta d theta. This is what we will get. Now in the next step, or the second step, if I substitute the value, then you can see that you will get a 1 by 3. Let us keep that outside. And this, if I simplify, will become nothing but d theta into sec square theta divided by, this will become x raised to the power 6 minus 1. X raised to the power 4 will go here. This is again, this part can be split and written into x square into x raised to the power 6 minus 1. And we can take x raised to the power 6 common from denominator. This will become x raised to the power 12. X raised to the power 6 plus 3 plus 1 by x raised to the power 6. Once we do this, you can see that this will get cancelled out. And then this x square x raised to the power 4 will also get cancelled out. So we are left with a very simple idea in the third step. and this looks something like this. We have 1 by 3. We have sec square theta. There is d theta. And what we have here, and of course we have a theta here. Now because we did this substitution, so this part will come. So this theta is there. And now this part, if you see, is nothing but x raised to the power 6 plus 3 plus 1 by x raised to the power 6. Which I, if simplify, in turn will become sec square theta d theta by. This can be written as nothing but x, this is nothing but square of this term that is given to us. So if I square this can be written as x raised to the power 3 plus 1 by x raised to the power 3 whole square plus 1 theta. See, now if I want to simplify this, the answer comes out to be nothing but this is sec square theta d theta. This will become tan square theta plus 1 theta. So this part and this part will get cancelled out. And ultimately we are getting a very simple integral. In the fourth part, that is nothing but integration of d theta by 3 into 1 by 3. This becomes ln of theta by 3 mod plus c, and which in turn can be written as nothing but ln of theta raised to the power 1 by 3 plus c. So you can see that this in turn is nothing but, if I put the value of theta, it is tan inverse x cube plus 1 by x cube ka mod raised to the power 1 by 3 plus c. And now if you check the options, this matches option A. Now next type of questions are based on by parts. So by parts, I already told you, works when the product of two functions is given to us. And this is a standard formula that we remember as first function into integration of second function minus integration of differentiation of first function into integration of second function plus c. Now this formula is a very important formula. We are going to use this, and this can be derived using product rule. So we will not go there. We'll just look into the applications of this. The first is based on Eilert rule. So in this function, it is critical that which function out of these two are you taking the first function. Because by doing the right choice, either the question will get solved or it will not get solved. So for doing that, we have a rule that is Eilert rule. So I-L-A-T-E. The rule says that the first, this is inverse function. L means logarithmic function. A means algebraic function. T means trigonometric function, and E means exponential function. So now what they're saying is, when we are applying this formula, we have integration of first function into integration of second function minus integration of differentiation of first function into integration of second function. So what is the important thing to observe here? See, there is one function that is getting integrated, there is another function that is getting differentiated. So if I choose the function that is difficult to integrate as the first function, my life will become easy. So you can see that if I am choosing function, it will make sense that I go from first function in this order. So always the inverse function over logarithmic function will get differentiated, and this will make our problem solving easier. Now let us see what kind of questions can be framed on this idea. Now let us look into this 2019 question. This question says that we have been given a function. Now if you look into this function, the interesting thing that you can observe here is what you have is x raised to the power 5 into e raised to the power minus x square. So what we will have to do is, first we will have to do a substitution, then we will apply by parts. In the first step, let us put minus of x square. In fact, x square is equal to t. If I do so, the derivative will become twice of x dx is equal to dt. In the next part, we are going to do the substitution. So x square, this will become nothing but x raised to the power 4, 1 by 2 will come. This will become e raised to the power minus t dt. Once you have got this, this can be replaced by nothing but 1 by 2 t square e raised to the power minus t dt. Now what we can do in this question is we can apply by parts. So based on Eilert rule, we'll take this as nothing but first function, this is nothing but second function. So I can apply my by parts, first function into integration of second function minus differentiation of first function into integration of second function. We have this. Once you have written this, we can write one more step and get an answer. So this becomes nothing but t square is fine. This will become e raised to the power minus t by minus 1. this minus 1 will take outside, this will become 2, this will become t e raised to the power minus t dt. Now you can see that I will have to apply it one more time, because in this case what we have is this thing. So again we'll apply in the same order, and very important to not change the order. And if I do so, this is minus 2 square e raised to the power minus t. This is 2. And now if I open this bracket, it is going to become first function into integration of second function, that will become this. Then minus differentiation of first function, integration of second function. And now again in this we'll apply integration one more time and get the answer. Also let us open the bracket. So t square e raised to the power minus t by 2. This becomes nothing but minus t e raised to the power minus t. This will become minus 2 e raised to the power minus t plus c. We have got the integral. Now the next part of the question says that if this function that we are writing, so let us write this function in the form of x. So in the third step, let us do it so. So my answer becomes nothing but x square was nothing but t. So t square will become minus x raised to the power 4. E raised to the power minus x square by 2. The next part will become nothing but minus of x square e raised to the power minus x square. And the last part will become nothing but minus 2 e raised to the power minus x square. Or this 2 will get cancelled out, so this 2 will not be there. So this is what we are getting. So what they are saying is this x wala part is nothing but now is important for us. So plus c let us write and then remove it. So now what they are saying is if I take e raised to the power x common, whatever is remaining is gx. So the value of gx from here can be written as minus of x raised to the power 4 by 2 minus x square minus 1, this function. So we are asking the value at minus 1. So let us put minus 1 in it. So if I substitute minus 1, what am I getting? This becomes minus 1 by 2 minus 1 minus 1. You can see that this is minus of 5 by 2. That is nothing but option D. If I look into this next question, we can apply by parts here right from the starting. So this function will consider as first function and this being function will consider as second function. So let us apply the formula. So first function into integration of second function by x tan x plus 1 whole square minus integration of differentiation of first function and then integration of second function, that is nothing but x sec square x plus tan x dx by x tan x plus 1 ka whole square. You have this. Once we have this, the interesting part comes into picture, that if you observe this integral, that is nothing but x sec square x plus tan x by x tan x plus 1 whole square. There is something very interesting happening here. See, this is an integral where whatever is written in the denominator, integral of differentiation of that is written in the numerator. So if I want to just integrate this, what I will do is I will put x tan x plus 1 as nothing but t, and you will see that this will become x sec square x plus tan x dx equal to dt. Now why this is so interesting? Because once you do this, what happens to this? This will become nothing but this will become dt. This becomes t square. Integration becomes minus 1 by t plus c. Now this we will use as a result in the above question. So if I use this in what we did earlier, we come with a very interesting idea. So this becomes x square minus 1 by t would be nothing but minus, let us write, and t was nothing but x tan x plus 1. Similarly in the other part, 2 we can take common. This will become plus. This is x already, and then here this will become x tan x plus 1 dx. So now this is the first part. We have solved it. Now in order to do this integration, what we are going to do is let us write it in the form of, so this is x tan x plus 1, and in the next part let us write it in the form of sine cos. So this will become x cos x. This is x sin x plus cos x. And once I write it to be so, what happens here is basically This part now I can put as t. X sin x plus cos x will be equal to t. And now in this, if I differentiate this, and now let us put this as v in order to avoid any kind of confusion. So what happens is this becomes nothing but sin x, and then this becomes nothing but x cos x. If I differentiate the second part, it becomes minus sin x. Dx is equal to dv, and this sin x gets cancelled out, and you can see that again you are getting the numerator. So what is the interesting part about this is basically now we can write this integral as nothing but whatever is written in the numerator is derivative of denominator. So now what we can do is, if I take this as v, this will become dv. And so interesting part here is we can directly write this integral as nothing but 2 times log of mod of v plus c. This is what we can do. Now this is very interesting because now we can put the value of v and we have got the value of the integral. So if I put the value of v, it is x square x tan x plus 1 plus 2 log of x times cos x, x times sin x plus cos x. This we are getting. Now let us go back to the question. They are saying that the value of this integral at 0 is equal to 0. So if I write the last part of the solution, what we can go and write is, if my integral's value at 0 is equal to 0, this will help us find the value of constant. So this was the value of the integral. If I put x equal to 0, you can clearly see that all other terms will become 0. So from this, what we are getting is value of constant is equal to 0. Now before we find the value of pi by 4, let us do minor correction. There is a minus sign here. So let us put that minus sign. And now let us find the value of I pi by 4 in the sixth step. So I pi by 4 will be equal to nothing but minus of x square, that is pi by 4 whole square, by x tan x plus 1, that will become pi by 4 plus 1, and then plus 2 times log of x sin x, so that will become pi by 4 into 1 by root 2 plus cos x, that is 1 by root 2. If I simplify this one, you can see that in this case your option A matches. Now let us look into this 2022 question. Again, in this question, if you carefully write it down, you might be able to understand what is happening. In the first part, if I split it up, you can see that this can be written as sec square x and cosec raised to the power 2022 x, and the second part can be written as nothing but minus of integration of 2022 cosec raised to the power 2022 x dx. Now this is what we are writing. Now here, see, this part is fine, this will remain as such, but in this first part we can apply by parts. We can take this as first function and this is second function. So this is my first function, this is my second function. If I apply by parts, it will become first function into integration of second function sec square x dx. Then we will have a minus sign. We will write differentiation of this function. So 2022 cosec raised to the power 2021 x. Then differentiation of cosec x will become minus of cosec x cot x. And then what we have is integration of the next function, that is nothing but sec x. That would be nothing but integration of sec square x. I can write this as 10x. Once we have written that, something very interesting happens. There is one more term, that is minus of 2022 cosec raised to the power 2022 x dx waiting for us. Now here you can see that this will get cancelled out, and now you can see that the same term that we are generating from here is written here. So this will get cancelled out, and ultimately what will come out of here in the next step is nothing but this integral comes out to be only the first term, cosec raised to the power 2022 x, and the into integration of sec x will become 10x and plus c. So this becomes the answer. Now in order to get the actual answer, we will have to substitute the value. They have given the value of pi by 4. So if I put pi by 4, this is 2 raised to the power 1011. So let us put pi by 4. So this will become root 2 raised to the power 2022. this will become nothing but 1 and this becomes c. So if I calculate the value of c from here, this is nothing but 1011. This is also 1011. Both of these terms will get cancelled out and c comes out to be 0. In the next part, in the third part, let us find the value of the expression. So now if you check the values, let us check for the first part. If I write 310, I am checking the option A into I pi by 3. Now what is I pi by 3? If I put pi by 3, this will become 2 raised to the power root 3 by 2 raised to the power. This is 2 by root 3 raised to the power 2022. And for pi by 3, this will become root 3. And the constant term is 0. And then we have minus pi by 6. So at pi by 6, this will become 2 raised to the power 2022 into 1 by root 3. Now if I simplify this, the first part, you can see that this becomes nothing but 2 by 2 raised to the power 2022 by 3 raised to the power 1011. We have 3 raised to the power 1010 into 3 raised to the power 1 by 2 minus 2 raised to the power 2022 by root 3. So what we can observe from here in the last part is, when we write this up, these terms will get cancelled out. If I cancel this, a root 3 will remain and this will cancel out and become 0. So you can clearly see that A option is matching. Now type 4 questions are nothing but by parts questions based on invisible second term. If I look into this part, you can see that if I want to integrate this, and this is also very important result, the second term is missing. The first function we can take as ln x. The second function will have to assume as 1. If I integrate this, the first function into integration of second function minus integration of differentiation of first function into integration of second function dx. If I simplify, this becomes x ln x, and this you can see that will become x. So this, if I further integrate, will become x plus. You can see that this type of question, and this is also important result to remember, in this the second term is invisible. Now there has not been a question in JEE Mains based on this idea, but it can be asked, hence I have quoted it in the one shot video. If I move towards the idea of regeneration, this is the type 5. In that, the older term will get regenerated. So a very good example of this would be nothing but this question: e raised to the power x sin x dx, and this question was also directly asked in the exam. So if I do this, what will happen is, I can take any one of them as first and second function. So I am taking this as first function, this is second function. So I can write this as sin x integration of e raised to the power x minus the differentiation of sin x will become cos x, integration will become ex dx. Again we will apply this idea one more time. So first part is fine, it remains intact. In the second one, I will follow the same order. So first function into integration of second function. Now if I write it down, you can clearly see that you can take it on the, this I got regenerated in the process. So this is e raised to the power sin x minus cos x, and I got regenerated in the process. This we can take on the left hand side. So 2 times I is equal to e raised to the power sin x minus cos x, and if I divide by 2, it becomes e raised to the power x by 2 sin x minus cos x plus c. See, now we can use this process. This process is known as regeneration because you can see that this I got regenerated. This is very important. Now we won't do every time this, and that is the reason we have reduced it into a formula. Now you can remember this result that is given here and directly apply it in solving the questions. If you can't remember, then use the original idea. Both are fine. You can see that in this case, when we are doing this, whatever is coming here, this term is getting repeated, so this term will remain intact. Here we will get a square plus b square, and then whatever we have written, we'll write it down. Whatever is the differentiation of this, that we will write it down. Put a minus sign in between and write a here and b here. Similarly, we can do it for cos bx plus c. Now when we are solving the question, there is a 2019 question then came on this idea. So in this question is given to us. It does not look out to be a question based on this idea. But if I do a substitution, what I can do is log of x I can put as t, or x we can put at e raised to the power t. Once we do this, the derivative of that will become e raised to the power t dt. And as a result, in the next step, this integral will become nothing but cos of t e raised to the power dt. And once you have this, now this comes into the standard form, e raised to the power cos of t dt. You can remember the result as well, and or you can do the regeneration part. Both of the things are fine. So in the third part, let us use the result. So from this result, you can see that if I have e raised to the power x plus cos bx plus c, what is going to be the answer? It is going to be the e raised to the power x by 2, cos x plus sin x plus c. This is what is going to come. So let us use this result here. So this is going to become e raised to the power t cos of t plus sin t plus c. This is going to be the answer. In place of t, we will write ln of x. So this will become x. This is cos of ln x plus sin of ln x or log x plus c. If you look into the option, you can see that clearly your A option matches. Now the type 6 problems are based on 3 important formulas. Now if I look into these 3 formulas, these are very standard results. I can very easily derive them. I am not going to do it. I am going to just show you using one example, just the first one. If you have e raised to the power x, here we are writing sin x and then the derivative of the same function is written in addition. We can write the answer of this function as directly nothing but e raised to the power x into the function that was written here. And now you can see that for if you have a gx in place of x, a g dash of x will come and rest of the things remain same. Another is x into f dash of x plus fx in a dx. Now this question has been asked less, the first two has been asked more. So we can focus on the first two more, but the last can also be asked. If I look into this 2022 question, the question says that integration of x square plus 1 e raised to the power x. So you can see that in this question we'll have to break it down. So let us break it down and figure out the answer. Now before doing this breakdown, there would be a very simple step. Just focus on this whatever is written here. That's whatever is written here. And our idea is to break it down into function and its derivative. So what I can do is I can write this as nothing but x square plus 2x plus 1 minus 2x by x plus 1 whole square. The reason behind that is the first function will become x plus 1 whole square. Second becomes 2x. Now I can divide by x plus 1 whole square in both the parts. And if I do it so, you can see that the first becomes 1. The second becomes 2x by x plus 1 whole square. Now again, you can see that, so my question is reduced into 2 questions. So if I again put integration of x square plus 1 by x plus 1 whole square e raised to the power x. By doing this, I have split it into 2 questions. One of them is, I can replace this by 1 minus 2x by x plus 1 whole square. And now if you write it down, this becomes e raised to the power x dx minus 2 times x e raised to the power x by x plus 1 whole square. This we have done. Now in the third part, since it is reduced into this question, this first part is very easy to calculate. It will become e raised to the power x. All effort is required to do the second part. Now in the second part, in the third step, let us see what do we do. So now this x upon 1 plus x whole square, we can add 1 and we can subtract 1. If I do so, now if you split it up again, the first part will become x plus 1 by x plus 1 whole square, and next becomes 1 upon x plus 1 whole square. So if I do it so, this becomes 1 upon x plus 1 minus x plus 1 whole square. Okay? So in the third part, now if I clearly see what is happening to this integral, you can see that the first part we have already resolved. This will become e raised to the power x. This is fine. And now in this integral, we have got e raised to the power x. You have got x plus 1. And then what we are getting is derivative of the same function. So this is function. This first part is nothing but the function. And the next part is nothing but the derivative of the function. So the answer can now be directly written as nothing but, this is e raised to the power x. This will become nothing but 2 times e raised to the power x into fx. This is the final answer. See, now if I do it so, you can see that if I want to find function, it is nothing but e raised to the power x into fx. So if I compare, I will get the value of function. My function as a result comes out to be nothing but 1 minus 2 by x plus 1. Now the question is saying that you differentiate this thrice and put x equal to 1. So if I take this function and differentiate it once, it will become 2 by x plus 1 whole square. If I differentiate it one more time, it will become minus 4 by x plus 1 whole cube. And if I differentiate it one more time, you can see that this will become 12 by x plus 1 raised to the power 4. So this becomes 12 by x plus 1 raised to the power 4. And if I put 1 here, let us see what do we get. This becomes 12. And this becomes 2 raised to the power 4, or 12 by 16. If I divide by 4, this is 3 by 4. Let us check the options. You can see that the B option matches. Now you can see that this next question is based on the another result. Let me quote the result for you. E raised to the power gx fx into g dash of x, then f dash of x. And it is based on this idea, and we know that the derivative of this function would be equal to, integration of this function would be equal, e raised to the power gx into fx plus c. If you compare, you can see that the value of gx here is nothing but sine square x. So if you differentiate this function, g dash of x will become 2 sine x cos x, that becomes eventually sine 2x. And this is what we are getting. Now once you have this, comes the another interesting part. You can see that here g dash of x is written, so this will become g dash of x. So this will become my function fx if I compare. So the function in this case is nothing but cos x. And then this should be derivative of the function, and that is apt because cos x derivative is nothing but minus sin x, and that is given to us. If you can observe this pattern in the first step, in the next one you will directly write the answer of this integral as nothing but fx, that is cos x, into e raised to the power sine square x plus c. This is what we are getting. Now what they are saying is e of 0 is equal to 1. Let us put x equal to 0. And this is 1. This will become also 1. And this will become c. So this will cancel out and the value of c comes out to be 0. In the third part, they want us to tell the value of nothing but e raised to the power, I of pi by 3. So I will have to replace x by pi by 3. And if I do so, this becomes cos of pi by 3, that is 1 by 2. Sine of pi by 3, that is root 3 by 2. This will become 3 by 4. This becomes 0. So 1 by 2 into e raised to the power 3 by 4. That is nothing but option D. Now type psi problem type is based on the idea of reduction formula. Again, this is one of the applications of by part. Reduction formula means that how to reduce higher powers in integration to lower powers. So it is always easier for us to integrate sine 3x compared to sine cube x. This would be difficult to do, this would be easier to do. So we will want to reduce this form into this form. So we are trying to reduce the powers. It is fine if the coefficient of x increases, it is still very easy to integrate. This idea is known as reduction formula. Now as a student, you should at least know these three reduction formulas. One is sine raised to the power nx dx. Another is tan raised to the power nx dx. And another one is nothing but cosec raised to the power nx dx. Now like sine, cos will work in the same manner, like tan, cot will work in the same manner, like cosec, sec will work in the same manner. So if I am looking into this, now let us look into the first idea how to do this. So in order to do this question, what we are going to do is, we are going to write this as nothing but sin x into sine raised to the power n minus 1 x dx. Now this will consider as first function, this is second function. Let us integrate. So sine n minus 1 x integration of sine x minus differentiation of first function, that will become n minus 1 sine raised to the power n minus 2x. Differentiation of sin x is cos x. Integration of this part will become minus cos x dx. Now once I have done this, you can see that the first part becomes sine raised to the power n minus 1x cos x. There would be a plus sign. This becomes n minus 1 sine raised to the power n minus 2x. And then what we have got is nothing but cos square x. Now this is an important term. We will use the identity that cos square x is equal to 1 minus sine square x and replace the value. If I do it, then let us see what do I get. So this becomes sine raised to the power n minus 1x cos x. This n minus 1 I can take common. This is sine raised to the power n minus 2x. 1 minus sine square x. dx. If I simplify, this becomes minus sine raised to the power n minus 1x cos x n minus 1 integration of sine raised to the power n minus 2x, and then again this will become minus n minus 1 integration of sine raised to the power nx dx. You can see that this part is now repeated or regenerated. We will call this as in. Since the power is n minus 2, we will call this as n minus 2. Let us take in on the other side. There is an in waiting for it. And if I take it, this will become n in is equal to minus sine raised to the power n minus 1x cos x. This is n minus 1 n minus 2. And if I want to get the answer, I will divide it by n and get the final answer. This formula that we have got is known as nothing but reduction formula. We have reduced the power of n to n minus 2. This is what we have fundamentally done. Now, what we have done here can also be applied to cos. Now, 2017 there was a question based on 10. Let us look into this question. What question says is, in is given, find the value of i4, i6. Now see, ideally speaking, if I want to get the reduction formula, what I am going to do here is, I am going to write this as 10 raised to the power n minus 2, and instead of 1 power, now I am going to take 2 power. And if I want to do this, this will become 10 raised to the power n minus 2x. This I will write as sec square x minus 1 dx. I can split it up. So this becomes 10 raised to the power n minus 2x sec square x. And then what we have in the other part is nothing but 10 raised to the power n minus 2x dx. In the first part, you can see that if I want to solve, I will just take 10x as t. So this integral will become 10x raised to the power n minus 1 by n minus 1. And the second part, and if I do, it will become nothing but in minus 1. So you can see that you have reduced the power of in. This will become the reduction formula. This is what we will also do with the cot, like I have done here. Now this question says that if you find the value of i4 and i6, it is going to be this. C is a constant, find the value of A and B. So see, now if you have figured out this section, this reduction formula, this is one method, then what you can do is you can put the value of 4 here. If you put the value of 4 here, this will become 10x raised to the power 3 by 3, and this will become i3. And similarly, we can find the value of I raised to the power 6. That will be 10x raised to the power 5 by 5 minus i5. Now what we can do in this case is basically we can add both of these and then see what happens. So this is one way to do the question, but in this case this method will become longer, might be a simpler method in some other question. So instead of doing this, I am adapting a simpler approach. So let me remove this and take a simpler approach in this case. So what I am going to do here is I am directly going to write i4 and i6. So if I write i4, it is nothing but integration of 10 raised to the power 4x dx. And if I write i6, it is going to become 10 raised to the power 6x dx. And I am going to directly substitute. So if I add both of these, it is going to become 10 raised to the power 4x plus 10 raised to the power 6x dx. And if I do in this manner, I can take 10 raised to the power 4x common. This is 1 plus 10 square x dx. As a result, this term will become sec square x. And now what has happened is we have 10 raised to the power 4x into sec square x dx. And now I can, after doing this first step, in the next step, I can directly put 10x as t. If I do it to be so, this becomes sec square x dx is equal to dt. And this becomes nothing but t raised to the power 4 dt. Now this can be easily integrated. This will become t raised to the power 5 by 5 plus c, or 1 by 5 10x raised to the power 5 plus c. If I compare it with the question that is given to me, you can see that the value of a came out to be 1 by 5. And since there is this term is not present, the b will become 0. What they're asking is the ordered pair. So it becomes 1 by 5 comma 0. That is nothing but option B. Now let us see this. In this question, we have a question based on cosec. So let us first understand, if I want to find the reduction formula, what is the way to find it in this case. So the standard method is, if you have cosec raised to the power nx dx, and this is also valid for sec, same method we can use there as well. We will be able to split it into cosec raised to the power n minus 2x into cosec square x dx. Now the idea is that this is going to be my second function, this is going to be my first function, and I am going to integrate. So if I do it so, first function, that is cosec raised to the power n minus 2x, integration of this will become minus cot x. The second part, the minus and minus will become plus. The differentiation, let us write minus only, will become nothing but n minus 2 cosec raised to the power n minus 3x. This will become minus of cosec x cot x. And the integration of next part becomes nothing but minus cot x. Okay? So this becomes minus of cosec raised to the power n minus 2x into cot x. And now this becomes minus of, let us also take n minus 2 outside. What is going to happen is, this is going to become cosec n minus 2x, and now what you have got as a result is nothing but cot x whole square dx. Cot square x can be written as nothing but cosec square x minus 1. So this is nothing but in. This minus cosec raised to the power n minus 2x cot x. This becomes n minus 2. And now this can be split and written as nothing but cosec square x minus 1 dx. You can see that you have got your reduction formula in the next step. So this will become minus of cosec raised to the power n minus 1 cot x minus n minus 2. And if I multiply this, this is going to become integration of cosec raised to the power nx dx. And then we will get again n minus 2. And now what is remaining is nothing but in minus 2. You can see that we have got in from here. We will take it on the other side. And as a result, we will get n minus 1 in is equal to minus of cosec raised to the power n minus 2 into cot x. And we have n minus 2 in minus 2. If I divide by n minus 1, I get my answer. So this is my reduction formula. Now once we have got the reduction formula, let us see how we will find the value of I5, because what is given to me is nothing but I5. In place of n, 5 is written. So if I figure out this value, this will become minus of cosec raised to the power 4x by 4 into cot x. If I put 5 here, it is going to become 3 by 4 I3. So in order to get this value, I will require I3. So let us put in place of n3. So if I put 3, it will become minus of cosec raised to the power 2x by 2 cot x, plus if I put 3, it will become 1 by 2 I1. Now see, I1 is something that you can directly find because it is integration of cos x dx, which in turn can be written as nothing but log of cosec x minus cot x. Once we write it down, this can be written as nothing but 1 minus cos x by sin x, and that in turn can be written as nothing but 2 sin square x by 2 by 2 sin x by 2, and this in turn will become nothing but log of tan x by 2. Now let us resubstitute the value. So this value of I1 will put here, and if I do so, the earlier expression comes out to be nothing but minus cosec square x by 2 into cot x plus 1 by 2 log tan x by 2. And moving forward, if I take this value of I3 and put here, it becomes minus of cosec raised to the power 4x into cot x by 4. this will become minus of, if I put I3 here, 3 by 4 will get multiplied, 3 by 4, and this will 2 will get multiplied. So 3 by 8 cosec square x, cot x, and the last one will come out to be nothing but 3 by 8 log of 10x by 2. If you compare the expression that we are getting here and the one that is given in the question, you will be able to recognize that in the last step that the value of alpha that we are getting from here is nothing but minus 1 by 4, and the value of beta is nothing but 3 by 8. So if I add these two and multiply by 8, so 8 times alpha plus beta if I do, it will be equal to 8 times 1 by 8, answer comes out to be 1. The next problem type that we are going to see is based on the idea of partial fractions. Now if I look into partial fractions, there are few things that we need to understand. It is the reverse process of LCM. So now there are 5 cases. I am going to take one question on each of these problem type to illustrate all of these cases. The type 8 problem is the first variation in partial fraction. If you look into this specific case, what we can do here in terms of partial fraction is, we can see that it is primarily a technique in algebra. So what we can do here is we can write x upon x minus 2 plus x plus 5 as nothing but a upon x minus 2 plus b upon x plus 5. And if I take LCM, you can see that the value of x would be nothing but a into x minus x plus 5 and b into x minus 2. If I want to get the value of a and b, the technique is very simple. We'll first put x equal to 2. So this is one technique. This is known as substitution. I will tell you 3 ways to do it. If I do that, the value of a from here comes out to be nothing but 2 by 7. In order to get the value of b, we'll put x equal to minus 5. And if we do so, left hand side becomes minus 5. This becomes b into minus 7. The value of b becomes 5 by 7. Now once we have done this, in the next part, that is the second part of this problem, what I can do is, I can write this integral x upon x minus 2 into x plus 5 dx as nothing but a, that is 2 by 7 integration of dx by x minus 2, 5 by 7 into integration of dx by x plus 5. Now the integration is very simple. Once you do, this is the answer you will get. Now you can see that this is very simple to do. The integration part is not tough. The only thing is how to split it up. So this is one technique. This was based on substitution. There is another technique. So this is technique 1. We can apply technique 2 here also. In technique 2, we can compare the coefficient. So for doing the same thing, I could have written the same thing from here onwards as nothing but x is equal to a plus b times x and 5a minus 2b. Now we can compare the coefficients of x and constant terms. If I compare constant terms, 5a is equal to 2b. And if I compare the coefficients of x, it becomes a plus b is equal to 1. If I put the value of b from here, it comes out to be nothing but 5 by 2 times a. And if I put this value here, this is a plus 5 by 2 times a is equal to 1. So a comes out to be 2 by 7. Hence the value of b comes out to be 5 by 7, and after that the process remains same. This is another technique. Now what we can do is, in this specific case, we have a shortcut. So instead of doing this technique 1 or technique 2, we can directly use the shortcut to write the answer in technique 3. In this technique 3, if you want to write the value of a, what I can do is, in this integral, you can see that below a is x minus 2. So you let go of x minus 2, and in this integral only, substitute the value of x that you will get corresponding to x minus 2 if you put it equal to 0. So what we will do is we will put x equal to 2. So this becomes 2, and 2 plus 5 comes out to be 2 by 7. Similarly, the value of b can also be figured out in the similar manner. So when you are doing b, below b is nothing but x plus 5. So we will remove x plus 5, put x plus 5 equal to 0, and we will put in place of x minus 5. This is minus 5 by minus 5 minus 2 becomes 5 by 7. So this is a very interesting technique that we can use to get the values of a and b faster, but it is only valid for the first case. Now in this 2023 question, The question is very simple. We can, in the first part, just substitute the value of x square as nothing but t. We can also put x square plus 1 is t. That is also possible. So there are 2-3 ways to do it. I will tell you both the ways. So one way is if I put x square is equal to t, then twice of x dx will be equal to dt. What is going to happen is this integration is going to become dt by t plus 1 and t plus 3. Now one way to do it will be to apply partial fraction, and I have told you a shortcut to do so. So the value of, if I want to write this, integration of dt by t plus 1, we'll put t is equal to minus 1 in the remaining part, so it becomes 1 upon minus 1 plus 3. And if I want to write integration of dt by t plus 3, instead of t plus 1, I will put t equal to minus 3. So this becomes minus 3 plus 1. Once you have done that, the answer becomes quite simple. It is 1 by 2 times ln of t plus 1. This becomes 1 by minus 2 ln of t plus 3 mod. This is what we are getting plus constant. Now, if I again simplify, it will become 1 by 2 times log of t plus 1 by t plus 3 mod plus c, and let us also replace the value of t with nothing but, so this becomes x square plus 1 by x square plus 3 plus c. So we have got the value of the integral. Now what they are saying is if f of 3 is equal to this value. So you can see that if I put f of 3, let us see what happens. If I put x equal to 3 here, so in the third part, what will happen is this integral will become 1 by 2 times ln of, and if I put 3, the numerator will become 3 square is 9 plus 1, 10, and denominator will become 3 square, that is 9, 9 plus 3, 12. So this becomes 5 by 6 plus c. So they have given the value of this as nothing but ln of 5 by 6, and you can see that if I calculate this, c will come out to be 0. In the next part, and that is the fourth part, what they are asking is the value of 4. So all we need to do is substitute 4 here. If I put x equal to 4, my answer becomes 1 by 2 log of 16 plus 1, this will become 17, and 16 plus 3, this will become 19. Let us check the option. So you can see that D option matches. Now this type 9 is another variation of partial fraction. In this case, what we have is a factor of x plus a and then x square plus b, something like that. The signs can, and the important part for this part is whatever this is quadratic expression, d is smaller than 0, so we can't factorize it. Instead of this, there can be x square plus bx plus c also. It does not matter. The d is smaller than 0. When you are writing the partial fraction, you will write it as nothing but a upon x plus a plus bx plus c upon x square plus b. This is important. Now let us look a question into this idea. This is given to us. So in the first part, let us write the partial fraction. This becomes 2x minus 1 by x plus 1 into x square plus 2. This can be written as a upon x plus 1 plus bx plus c by x square plus 2. Now if I take LCM, this will become 2x minus 1 is equal to a into x square plus 2. And then bx plus c into x plus 1. Now if I want to find the value of a, I am using substitution method. We'll use combination of techniques. So if I just want to find the value of a, I'll put x equal to minus 1. And if I do it so, this becomes minus 3. And then this becomes nothing but a into 3. This part becomes 0. The value of a comes out to be minus 1. Now in order to find the value of b, what we can do is we can compare the coefficient of x square. So you can see that I am using a combination of earlier both techniques. So coefficient of x square from the left hand side is 0. From the right hand side it will become a plus b. So value of b becomes minus a, and that becomes plus 1. Now in order to get the value of c, there is an easier technique into place. What we can do in order to get the value of c is, I can put the value of x equal to 0. If you put x equal to 0, left hand side becomes minus 1. Right hand side becomes 2a. plus c. You can see that c from here comes out to be minus 1 minus 2a. A is minus 1. This will become plus 1. You can see that the value of c comes out to be 1. Now once you have done this, in the step 3, let us try and integrate. So the first integration we are getting is a times. A came out to be minus 1 dx by x plus 1, and then b x plus c. So what is the value of b here? B came out to be 1, c also came out to be 1. So this is nothing but x plus 1 by x square plus 2. Now we'll have to integrate this and get the answer. So if I want to integrate the first part, it becomes log of x plus 1 mod. So this was easier to get. If I want to integrate the second part, I will have to use another technique. Let us look into the technique for the next one. So let us do this first. So what I will do is, I will again try and split this x plus 1. So what we are doing is, and this we will learn again in detail, I will write this as nothing but 2x into 1 by 2 by x square plus 2 plus integration of dx by x square plus 2. Now you can see that both are quadratic, but if you want to integrate the second part, it will become 1 by 2 log of x square plus 2. The reason is that whatever is, there is the derivative in the numerator and the function in the denominator. So this shortcut you should always remember, and this will use quite often. We have f dash of x by fx. We'll write the answer is nothing but ln of fx mod plus c. Okay, there is one more that we use. Let me quote that as well. So another one that we use is f dash of x by fx raised to the power n. You can see that here what is happening is n is not equal to 1 when we are writing this. So what will happen? This will become fx raised to the power minus n plus 1 by minus. These are the two shortcuts that we'll be using quite often. So here we can directly use it. For the another part, it becomes a formula of 1 by a tan inverse of x by a. You can have got the integration of the second part. First part we already got, so we have got the final answer. You can see that this kind of technique is very useful in solving questions. JEE has not asked a question on this, but there can be a question, hence I am discussing it. If I move to type 10 of partial fraction, you can see that in this type 10, there was a question asked, and what is happening here is basically they are talking about square of things. So what is happening in this is we have been given a question that looks like this: x minus 1 into x minus 2 whole square dx. If somebody gives you a question like this, what is going to happen? The partial fraction can be written as a upon, partial fraction can be written as 1 upon x minus 1 into x minus 2 whole square in the first step. Nothing but a upon x minus 1. Then b upon x minus 2 and c upon x minus 2 whole square. Finding the value of ABC will follow the same process. And if I want to solve, and again I will take the LCM. The next part, so 1 will be nothing but a into x minus 2 whole square, b into x minus 1 into x minus 2, and c into x minus 1. If I want to get the value of a, again I can do substitution and put x equal to 1. So this becomes 1, this becomes 1, this becomes 0 and 0. So a comes out to be 1. In order to find the value of b, it would be easier to find c first. We'll put x equal to 2. So left hand remains same. This becomes 0. This also becomes 0 and this becomes 0. C also comes out to be. In order to get the value of b, we can compare the coefficient of x square on both the sides. So left hand side it is 0. Right hand side it would be nothing but a plus b. So from here b comes out to be equal to minus a, and that is equal to minus 1. So you see that you have got all the three values. Integration after this is extremely simple. The third step, let us do integration. So integration will become a. So a was nothing but 1 into 1 upon x minus 1 dx plus b, that is nothing but minus 1 into integration of 1 upon x minus 2 dx, and then c, that is nothing but 1 into 1 upon x minus 2 whole square dx. If you simplify this, this becomes nothing but log of x minus 1 mod minus log of x minus 2 mod. This last one will become nothing but minus 2 by x minus 2 raised to the power minus 1 by minus 2 by minus 1 plus c, sorry. You can see that you have got the answer for this as well. Check the calculation if there is something. But this is the method that we can use to solve such question. If I look into this 2023 question, this question says that we have been given this function. Such functions, usually we'll have to put this to simplify it. Then the first step, let us do that. Let us put 1 plus x e raised to the power x as nothing but t. And if I put it to be t, then you can see that after differentiation, this becomes e raised to the power x plus x e raised to the power x dx is equal to dt. In the next, if I substitute, let us see what happens. So you can see that this will be nothing but see x plus 1 into e. So x plus 1 will get adjusted here. But e raised to the power x we will have to take in the denominator, and this will become t whole square dt. If I write this, x e raised to the power x can be resubstituted from here. This becomes dt by t square into t minus 1. So in the third step, I can express the same integral or 1 upon t square into t minus 1 as nothing but a by t b by t square plus c upon t minus 1. And if I do it so, I can simplify and write this as a into t minus 1, b into t minus 1, and c into t square. See, now the job is very simple. We need to find the value of ABC, and for doing that, let us do substitution. So I can put t as nothing but 0. And if I do it so, left hand side becomes 1. B part becomes b into minus 1, and the value of b comes out to be minus 1. If I want to do this for t equal to 1, let us see what happens. If I put t equal to 1, left hand side remains 1. This becomes 0, 0. This becomes c. So value of c comes out to be 1, and then we can compare the coefficient of x square on both the sides. So left hand side is 0, right hand side it becomes a plus c. So the value of c, in fact a comes out to be minus c, that becomes minus 1. So we have figured out the value of ABC. In the fourth step, we are going to integrate. So in the fourth step, if I integrate, it will become integration of a, that is minus 1, by t, then b, that is minus 1 dt by t square, and then c, that is 1 by dt by t minus 1. And if I do it so, this becomes minus of ln mod of t plus 1 by t plus ln of t minus 1 mod plus c. If I simplify this, let us see what is the value of t that we are getting. So if this becomes 1 by t plus ln of t minus 1 mod by mod of t plus c. Once we have done this, now let us go back to the question. The question says that if I put x tends to infinity, the value of this I should be equal to 0. So now if I do that, so when x tends to infinity, x into e raised to the power x will become infinity. And our t was nothing but 1 plus x e raised to the power x. So your t will also tend towards infinity. And as a result, 1 by t will tend towards 0. The value of this integral, if I want to find at 0, this will become 0. This will become log of 1. This will become c. Now this is 0. So c will also come out to be 0. In the next part, that is the fifth part, they are asking us to find the value at 1. So if I put t is equal to x is equal to 1, correspondingly t will become 1 into e raised to the power 1 plus. And as a result, t comes out to be nothing but e plus. If I substitute this value, the value of the function I at 1 comes out to be nothing but this will become nothing but 1 upon e plus 1 plus log of e plus 1 minus 1 by e plus 1, and c came out to be 0. So if I simplify this, my answer to this question comes out to be 1 upon e plus 1 plus, this becomes nothing but ln of e, that will become 1, minus ln of e plus 1. So the final answer ultimately comes out to be nothing but, if I add both of these, it comes out to be nothing but e plus 2 by e plus 1 minus of ln of e plus 1. And if I calculate this, you can see that it matches nothing but option C.
Now in this next variation of partial fraction, we are going to look into a partial fraction where we have even powers of x, you can see. So what you can do is, when you are doing partial fraction, when we are writing this function, for doing partial fraction, we can assume x square is nothing but t. This expression reduces itself into t upon t plus 1 into t plus 2. And now we can see that after doing this substitution, this reduces into type. And I can use shortcut to write the answer as nothing but 1 upon t plus 1. If I write, I will put minus 1 in the remaining. So minus 1 by minus 1 plus 2. And then for the 1 upon t plus 2 part, I can put minus 2 in place of t. So minus 2 by minus 2 plus 1. You can see that the partial fraction part becomes easy, and after that we can re-substitute t as 1 by x square, t as x square. So this becomes nothing but minus of 1 by x square plus 1. And next part becomes nothing but 2 times 2 by x square plus 2. Now once we have done this in the first part of the question, in the second part the integration becomes extremely simple. It will become minus 1 upon x square plus 1 dx plus 2 times dx by x square plus 2. And if I write this down, I can apply my formula. So 1 by a tan inverse of x by a, this will become 2 by root 2 tan inverse of x by root 2 plus c. You can see that integration becomes extremely simple, and we get our answer as minus tan inverse x plus root 2 by 1 tan inverse x by root plus c. Now in this type 12 problem of partial fractions, you can see that the degree of the numerator is greater than degree of denominator. Now partial fractions, any traditional technique can't be applied until unless it is a proper rational polynomial, and that can only become if the degree of numerator is smaller than degree of denominator. So in this case, what we need to pay attention is this basic idea that first we'll have to lower down the degree of numerator, and for that we'll divide the numerator, that is x cube minus 6x square plus 10x minus 2 by denominator, that is x square minus 5x plus 6. So we'll write x here. This will become x cube minus 5x square plus 610. So this will become minus plus minus. So this becomes nothing but minus x square plus 4x minus 2. You can write minus 1 here. This becomes minus x square plus 5x minus 6 plus minus plus. So this becomes nothing but minus x. This becomes nothing but plus 4. You can see that in the next part, if you write it down, this question, the numerator can now be written as nothing but x square minus 5x plus 6 into x minus 1 and minus x plus 4 as the remainder. If I now divide by the denominator, you can see that it will get split into two different integrals. Solving both of them separately, we can get the answer. So let us write the first one. So x square minus 5x will cancel out. So this is x minus 1 dx. And for the next one, you can see that it again becomes a question of partial fraction, because we can rewrite the denominator as x minus 2 into x minus. So now you can see that both of these integrals can be solved. This is nothing but a type 1 of partial fractions. It can be 2, 3 as well. But in this case, 1 is getting formed. Important thing to understand is if the degree of numerator is greater than degree of denominator, divide and then solve the question. Now, type 13 question now based on trigonometric integrals is based on this kind of a quadratic expression in sine cos in the denominator. If I want to solve this, the standard technique is to divide numerator and denominator both by cos square x. You can also divide it by sine square x. As a result, we will be able to generate sec square x in the numerator and a quadratic equation in 10x in denominator. And now if you put 10x equal to t, this will reduce into dt by at square plus bt plus c. So this is 1 by quadratic form. We have lot of standard formulas to solve this question. Now this 2024 question targets such kind of question. So what we can do in this question is, I can just take or divide the numerator and denominator by cos square x. So this becomes sec square x dx by a square tan square x plus b square. And now what we can do is we can take 1 by a square common. So this is nothing but sec square x dx by tan square x plus b by a whole square. Now in the next step, we can put tan x as t. So differentiation becomes sec square x dx is equal to dt. So the value of the integral comes out to be 1 by a square dt by t square by b by a whole square. And if I integrate, I have a direct formula 1 by a. So here a will become b by a and tan inverse of x by a. So this will be t by b by a plus c. So if I simplify this, this becomes 1 by ab. This becomes tan inverse a t by b. T is nothing but tan x. So resubstituted, this is what we get. When the question they are saying the answer is this. So if I compare both of these values, you can see that your AB will be equal to 12 and the value of A by B will be equal to 3 if I compare. So this is the third part of the question. And now if you have this, from here the value of A will become 3B. You can resubstitute this value here. So 3b square will be equal to 12. The value of b comes out to be plus minus 2. I am taking plus 2 because it is not going to impact the answer. Now from here the value of a comes out to be 6. Now in the fourth part of the question, what they are asking is nothing but what is the maximum value of a sin x plus b cos x. We know that the maximum value is nothing but root of a square plus b square. And if I put the values, this comes out to be root of 40. That is nothing but option C. Now if I look towards this 2018 question, the denominator, if you carefully observe, I can group these two terms. It is in the standard form only but slightly different. So let us do 1 or 2 steps to simplify things and then we'll do what we are doing earlier. So if I simplify this, you can see that I will be able to take sine cube common from the first pair and cos cube common from the second pair. And if I take this common in this first place, you can see that sine cube x will come common and then sine square x plus cos square x will remain and this will become 1. So ultimately this term will reduce to sine cube x. Similarly in the second pair, the similar thing will happen, it will reduce to cos cube x. Because whatever is inside will become cos square x plus sine square x. So it comes out to be cos cube x. As a result, what we are writing here will simplify into sine cube x plus cos cube x whole square and dx. And now if I take cos cube x common, it will become cos raised to the power 6x. So that is nothing but tan square x into sec square x dx divided by tan x whole cube plus 1 whole square. Now what happened after doing this simplification? The first step is, the second step has become extremely simple. We can put tan x whole cube plus 1 as nothing but t. The benefit of doing this is if you differentiate, this becomes 3 tan square x into sec square x dx is equal to dt.
So if I substitute this value, my integral reduces itself into 1 by 3 times. The numerator will become dt. Denominator will become t square. Answer becomes minus 1 by 3 into 1 by t plus c. So if I compare the options and if I put the value of c, you can see that my B option matches. Now type 14 question is, we have got the similar kind of expression as earlier, but instead of square, the square is gone. So now in this case, what we are going to do is, we are going to put sin x in terms of half angle formula of tan. So tan x can be substituted as 2 tan x by 2 plus 1 plus tan square x by 2. And cos x can be substituted as 1 minus tan square x by 2 by 1 plus tan square x by 2. So if I do this, you can see that in the next question, what is going to happen? This will become 3 into 2 tan x by 2 by 1 plus tan square x by 2. And this will become 4 times 1 minus tan square x by 2 by 1 plus tan square x by 2. Once this happens, we can take this 1 plus tan square x by 2 in the numerator. Denominator will become 6 tan x by 2 plus 4 minus 4 tan square x by 2. So you can see that this 1 plus tan square x by 2 in turn can be written as nothing but sec square x by 2 dx. What we can write here is minus 4 tan square x by 2 plus 6 tan x by 2 plus 4. This is the first part of the question. Now in the next part of the question, we will do substitution. So what we can do is, we can put tan of x by 2 as nothing but t. The differentiation becomes sec square x by 2 into 1 by 2 dx equal to dt. And if I put these values, let us see what happens in the question. So if I do this, my question reduces itself into nothing but I will be equal to integration of dt. And then you have 1 by 2. So that will go on the other side, will become 2. And in denominator, you are going to get a quadratic. So this becomes minus 4t square plus 6t plus 1. And now in order to integrate this, we will have to take minus 4 common. So 2 by minus 4. This will become dt. T square minus 3t by 2 minus 1 by 4. You can see that now we are going to generate a perfect square denominator, then apply the standard formula and get the answer. So this becomes dt by t minus 3 by 4 whole square minus 9 by 16 minus 1 by 4. So this becomes minus 1 by 2 dt by t minus 3 by 4 whole square. And if I multiply 4, this will become minus 13 by 4. You can see that now we have got it in the standard formula form. We can apply the formula, get the answer. So it will become 1 by 2a. Now this is a standard formula. I am going to leave it here. You can solve and get the final answer. If I look into type 15 questions, you can see you have a linear expression of sine and cos divided by linear expression of sine and cos. The technique is very simple in this case. We will write numerator as nothing but a times denominator plus b times d by dx of denominator. This is the technique. Now let us see how can it be implemented in this question that is given to us. We can write numerator, that is sin x, as nothing but a times denominator. So sin x minus cos x plus b times derivative of denominator, that will become cos x plus sin x. If I want to get the value of a and b, I can do substitution also, I can do comparison also. In this case, I am doing comparison. So I can write the coefficient of sin x as nothing but a plus b. And for cos x, it will become minus a plus b cos x. If I do it in the next step, if I compare, a plus b should be equal to 1, and minus a plus b is equal to 0. If I put the values here, a will be equal to b will be equal to 1 by 2. This is what we are getting. In the next step, if I want to integrate, now the numerator can be split, or the integral will be split into two parts. The value of a we have figured out is 1 by 2. Into the first part, that is sin x minus cos x. Divide by sin x minus cos x. And then we will have b. So let us also write b again, which was 1 by 2 times derivative. So that was nothing but cos x plus sin x by sin x minus cos x. If I want to integrate this, the next step would be, this will get cancelled out. So this becomes 1 by 2 times x. And the next part will become nothing, but you can see that I have already told you this shortcut. If you have derivative of a function fx by fx dx, the answer will become nothing but log of mod of fx plus c. So we can use this idea in this question and directly write the answer is nothing but log of sin x minus cos x mod plus c. And this 2024 question is based on the exact same technique. In this, we can write the numerator and after simplification in sin cos form. So this will 2 times sin x by cos x by 3 plus sin x by cos x dx. Now if I write it down like this, it can be simplified and written as nothing but 2 cos x minus sin x by 3 cos x plus sin x dx. Now in the second part, I am going to write numerator, that is 2 cos x minus sin x as nothing but a times denominator, that is 3 cos x plus sin x, plus b times differentiation of denominator, that is minus 3 sin x plus cos x. If I write it like this, I can compare the coefficients of sin and cos. So the coefficient of sin becomes a minus 3b sin x. Coefficient of cos becomes 3a plus b cos x. So if I compare the coefficients, a minus 3b should be equal to minus 1. And then 3a plus b will be equal to minus 1, will be equal to 2. We have got two equations, two unknowns, and now we can figure out the value of a and b. Let us do it. So if I want to figure out the values, so if I take the value of a and substitute in the second equation, the value of a comes out to be from the first equation is minus 1 plus 3b. If I substitute in the second, 3 times minus 1 plus 3b plus b will be equal to 2. If I simplify, this is minus 3, 9 plus 1, this will become 10b, this will be equal to 2. So b will come out to be nothing but 1 by 2. Now once I have got the value of b, correspondingly if I put here, a would be nothing but minus 1 plus 3 by 2. So it will come out to be 1 by 2. So we have figured out the value of a and b. A is 1 by 2, b is also 1 by 2. So once we have figured out both of these values, now let us put it in the original integral. So in the third part of the question, yes. In the third part of the question, if I write, it is a times, a was nothing but 1 by 2. The denominator, that was 2 cos x plus sin x by 2 cos x plus sin x dx, and then again b times differentiation of denominator, that is minus 2 sin x plus cos x by 2 cos x plus sin x dx. Once I have done that, now the first integration is very simple because both of these terms that we have written here and here will get cancelled out. It will become 1. So integration becomes 1 by 2 times x. For the second part, whatever is the numerator is the differentiation of denominator. So this becomes ln of 2 cos x plus sin x ka mod plus c. Now the question says that they have also given the answer. It is nothing but alpha by 2 into x. So if you compare the value of alpha in the fourth step, comes out to be nothing but 1. And then log of, you can see that and a beta sin x. So beta sin x, beta will become 1 and gamma will become 2. So we have the value of alpha, beta, gamma. Now what they are asking is alpha, that is nothing but 1 plus gamma by beta, that will become 2. So answer to this question becomes 3. If I integrate this, let us see what do I get. So the first part will cancel out and become 1. So this becomes 1 by 2 times x. The second, the differentiation is the numerator, function is the denominator. So this becomes ln of 3 cos x plus sin x ka mod plus c. If you compare in the fourth part, the value of alpha comes out to be 1. Beta is nothing but the coefficient of sin x. So beta comes out to be 1. And gamma is that for cos x. So this comes out to be 3. If I want to find the value of alpha plus gamma by beta, it is 1 plus 3. Answer comes out to be 4. If I look at this type 17th trigonometric problem, it is of the form integration of sin raised to the power mx into cos raised to the power nx. Now there can be few cases in this. Let us see them one by one in form of problems. One is basically, you can see here, the power of sin x is odd, cos x is even. So what we can do here is, we can put the one with cos x higher power here as nothing but t. So what will happen? Minus of sin x dx will be equal to dt. And as a result, if I do substitution, one sin x will go away, minus will remain. There will be a sin square x d raised to the power 5 dt. Once you have this, this will become minus. This will become 1 minus t square into t raised to the power 5 dt. And if I simplify this, it becomes minus of t raised to the power 5 dt and plus t raised to the power 7 dt. So this becomes minus t raised to the power 6 by 6 plus t raised to the power 8 by 8 plus c. If I put the value of t in the next step, I have got my answer in the next part. So t we put as nothing but cos x. So this will become minus of cos x raised to the power 6 by 6 plus cos x raised to the power 8 by 8 plus c. In this next part of problem, you can see that the one with the even power, either sin or cos, we can put as t. You can see that now one is odd, one is even. So the one with the even, I am putting that as t. And if I put that, it will become minus sin x dx is equal to dt. And this first part now will become sin raised to the power 4x. This will become t raised to the power 4 dt. Now what was the reason behind doing so? Because now you can see that here we have got even power. This can be written as 1 minus cos square x. So that will become t square whole square. It can be expressed in the form of cos. That is the reason. So now I can open this bracket up. This will become 1 plus t raised to the power 4 minus 2t square into t raised to the power 4 dt. And that becomes minus of t raised to the power 4 minus of t raised to the power 8 dt plus 2 t raised to the power 6 dt. Now this can be very easily integrated. And answer becomes minus of t raised to the power 5 by 5. T raised to the power 9 by 9 plus 2 t raised to the power 7 by 7 plus c. In the second part, we can put the value of t as cos x. So this will become minus of cos raised to the power 5 by 5 minus cos x raised to the power 9 by 9 and plus 2 times cos x raised to the power 7 by 7 plus c. Now in this next question, you can see that both the powers are even. So in such cases, no substitution will work. There is no substitution that will work. So what you will have to do eventually is you will have to apply trigonometry, simplify and then do the question. So what we are going to do is, for this, let us first remove the integral sign and simplify it using trigonometry. So sin square x can be written as 1 minus cos 2x by 2. And cos square x can be written as 1 plus cos 2x by 2 whole square. If I simplify this, the first, we will be able to take 1 by 8 common. This is 1 minus cos 2x. This will become 1 plus cos square 2x plus 2 cos 2x. Now, if I simplify this, you can see that, let us first simplify this power. This will become 1 by 8. 1 minus cos 2x is fine. This part can be written as nothing but 1 plus cos of 4x by 2 plus cos 2x. And now we can start opening the brackets. And if I open the brackets, you can see that first term will become 1 plus cos 4x by 2 plus 2 cos 2x. And then the next one, if I multiply by cos x, this will become minus cos 2x. And then you have 1 by 2. So we could have written this is nothing but 3 by 2 in the earlier stages and save some effort. So this will be 3 by 2 plus 1 by 2. So this also we could have directly written as nothing but 3 by 2. And now when we are multiplying, again it will become easy because this will become 3 by 2. And the next part will become nothing but 1 by 2, and we will get a minus sign also. So minus of cos 4x into cos 2x and minus of 2 cos square 2x. Now you can see that if I simplify it further, it will become nothing but 1 by 8 times this 3 by 2 is fine. In fact, this cos 4x by 2 is also fine. I have also no problem with this 2 cos 2x. But I can combine these two and write it as nothing but 1 by 2 times cos 2x. Now this is also fine. Now we will want to split this term up. In order to split it up, I will have to multiply and divide by 2. So this is 2 cos 4x cos 2x. And then this I will have to reduce the power. So I will write this as nothing but 1 plus cos 4x. So once I simplify this, 1 by 8 is fine. It can remain outside. This is 3 by 2. This is cos of 4x by 2. This is cos of 2x by 2. And then I can split this up. This can be written as cos of 6x plus cos of 2x minus 1 minus cos 4x. Now once I simplify this, I will be able to get my answer. So you can see that 3 by 2 is fine. There is cos 2x by 2 here, cos 2x by 4 here. If I simplify, this will become cos 2x by 4. So these two terms are sorted. And I have minus cos 4x and cos 4x by 2. So this will become minus of cos 4x by 2. Then I have this 6 wala term. So that will become minus 1 by 4 cos of 6x. So once we have written it in this manner, so it is primarily a problem of trigonometry. Once you have simplified it, now the integration part, that is the second part of this question, will become extremely simple. So if I integrate, you can see that 1 by 8 into first part will become nothing but 3 by 2. This can be integrated simply. Second part will become integration of 1 by 4 into 8 is 32. So let us write 1 by 32 out. Integration of cos 2x dx. Next part is nothing but 1 by 2 multiplied by it will become minus 1 by 16. Cos 4x dx. And at last I have minus 1 by 4. This will become 4 into 8 is 32. So this will become minus 32 cos of 6x dx. Now we can see that each of this is very simple to find. First will become 3 by 16x. Second will become 1 by 32 is fine. This will become sin 2x by 2. The next will become minus 1 by 16 is fine. Sin 4x by 4. And the last one is nothing but minus 1 by 32 is also fine. This will become sin 6x by 6. So we have figured out the answer. So if you look into this solution, 90% of it is in the trigonometry. So you need to be careful in questions involving sine and cos whose both powers are even. Now the fourth kind of question that are based on this, and it was also asked in 2019, is the one where we have these kind of powers. And the interesting part is, if I write it in terms of sine cos, so this can be written as cos of minus 2 by 3. This can be written as sine of minus of 4 by 3. So if I add up the powers, so minus 2 by 3 minus 4 by 3 comes out to be minus 2. That is nothing but an even negative integer. If this happens, this is the problem type, fourth problem type. So what we are going to do in this problem is interesting. We are going to multiply. So here what we have is sine minus 4 by 3. I am going to divide by cos of minus 4 by 3 and multiply with the same. So this will become cos of minus 2 x dx. Now what we can do is, this will become 10x raised to the power minus 4 by 3. And this becomes sec square x dx. So in the third part of this discussion, we will put 10x as t. This becomes sec square x dx as nothing but dt. Now this will become nothing but t raised to the power minus 4 by 3 dt. Integration of that becomes t raised to the power minus 4 by 3 plus 1 by minus 4 by 3 plus 1 plus c. We have got our answer. So my answer comes out to be nothing but 10x raised to the power minus 1 by 3 by minus 1 by 3 plus c. Let us check the option. You can see that my B option comes out to be correct. If I look into this 2019 question, first we'll have to do a substitution. So here, if I substitution x as sin theta, let us see what do we get. Dx will be equal to nothing but cos theta d theta, and if I substitute it here, numerator will become cos theta. 1 cos theta will come from dx part, and denominator will become nothing but sin raised to the power 4 theta. If I simplify this, you can see that in the numerator we have cos square theta d theta. And if I bring my, just to check out, minus 4 theta d theta, then you can see that the sum of the powers of sine and cos is now becoming an even negative integer. So we'll have to do the 10x wali thing. So just wanted to portray this. Now what we will do is, basically we are going to generate a 10x out of it. So I have multiplied and divided by cos raised to the power 4 theta in the denominator. And if I do it, then let us see what do we generate. As a result, you can see that these two will combine and generate sec square theta d theta and divide by 10 raised to the power 4 theta. In the next or the second step, we are going to put 10 theta as nothing but v, and if I put it, then this is going to become dv by v raised to the power 4, and that will become v raised to the power minus 3 by minus 3. That is minus 1 by 3. V was nothing but 10. So this becomes 10 raised to the power minus 3 theta plus c. In the third step, let us do the resubstitution part. A 10 theta, if I want to put, I will have to put back in terms of sine and cos. So this will become sine raised to the power minus 3 theta by cos raised to the power minus 3 theta. This we can write as nothing but cos cube theta by sin cube theta. There is a plus c always. And now if I simplify it, this will become nothing but root of 1 minus x square whole cube. And this will become nothing but x cube. So now if I go back and check what is written in the question, what they are saying is ax. So if I figure out this ax function is nothing but minus 1 by 3x cube. And then they want me to raise it to m. So my m is nothing but 3. So this will become minus 1 by 3x cube raised to the power 3. So minus 1 by 27x raised to the power 3. That becomes nothing but option C. Now type 18 trigonometric integrals are based on the idea of sin of x minus a by cos of x minus b. In such questions, whatever is in the denominator, this part we will put as t. So x minus b will put as t. This is how we are going to solve such question. Now, if I look into this question that came in 2019, this is a question based on similar idea. First, we'll have to convert in the form and then we'll have to do the substitution. Let us see how it works out. So, in step 1, we are going to write it in sin cos form. So, sin x by cos x plus sin alpha by cos alpha divide by sin x by cos x minus sin alpha by cos alpha. Now if I take LCM and simplify, numerator will become sin x cos alpha plus sin alpha cos x divided by sin x cos alpha minus cos x sin alpha. And we can simplify this and write the numerator as nothing but x plus alpha. And denominator now is nothing but x minus alpha. So you can see that this question reduces into the form that we are talking about. So in the second part, if I want to solve this, substitution is very simple. We have x minus alpha in the denominator, let us put it equal to t. And as a result, dx will be equal to dt. There will be no change. So the numerator becomes sin of. In place of x, we can write t plus alpha. So this becomes t plus 2 alpha dt. And then we have divided by sin t. Now in the next step, if I want to solve it, in the third step, we are going to expand the numerator. So sin t cos 2 alpha plus cos t sin 2 alpha. And let us also distribute sin t in the denominator. And once I have done this, and if I simplify, the first part, sin t will get cancelled out. Cos 2 alpha can be taken out. This will become dt. The second part, sin 2 alpha can be taken out. And this will become cot t dt. And integrate it. The first part will become cos of 2 alpha into t. The second part will become sin of 2 alpha into log of sin t plus c. So, if I substitute the value of t, this is cos 2 alpha into x minus alpha. Then sin 2 alpha into log of sin of x minus alpha come mod plus c. You can see that the a raised to the ax, what they are saying is function is nothing but x minus alpha. That matches B option. And that bx is also sin of x minus alpha. ln of sin of x minus alpha, that also matches B option. Now in this type 19th problem type of trigonometry, you can see that we have been given a function of sin x, where sines are multiplied. See, now whenever trigonometry functions are involved, we'll prefer them to be added than multiplied. So if it is given in this form, we'll want to express them as sum of trigonometric ratios. So this is primarily again a question of trigonometry. This is given to us sin x Sine 2x, sine 3x. I am going to multiply and divide by 2. And this 2 sine x and sine 3x will combine and will split them. So if I split them, it is going to be cos of subtraction of this angle, that will mean cos x, minus cos of addition of this angle, that will mean 4x. Now again we can open up the bracket. This will become sine 2x into cos x minus sine 2x into cos 4x. Again, to expand, we can multiply and divide by 2. And now again I am going to simplify this. So this is going to become nothing but sine of this angle plus this angle, that will become 3x, plus sine of this angle minus this angle will become x, minus again sine of sum of the angles, that will become 6x. And then since 2x is smaller than 4x, there will be a minus sign, so this will become sine 2x. In the next step, we can simplify it. It can be written as 1 by 4 times. The smallest one is nothing but sine x. Let us write that. Then the next one is sine 2x. Then the next one is nothing but sine 3x. And then we have minus of sine 6x. You can see that now it has 4 parts that can be easily integrated. Then the next part, if I integrate, I will get 1 by 4 times integration of sine x dx plus 1 by 4 times integration of sine 2x dx, 1 by 4 times integration of sine 3x dx. And the last thing, that is nothing but minus 1 by 4 times integration of sine 6x dx. If I integrate this, integration of sine x is minus cos x, so this will become 1 by 4 with a minus sign minus cos x. This will become minus 1 by 4 cos 2x by 2. The next one will become minus of 1 by 4 cos 3x by 3. And then plus 1 by 4 cos 6x by 6 plus c. So we have got our answer. Now in the first one we had used sine cos technique. Here we are going to use tan cot technique. So tan cot technique does not start from splitting directly. It starts from angle. So we will write 3x as nothing but x plus 2x and then take tan on both the sides. So in tan and sine question, this is the fundamental difference. If you understand this difference, you can solve questions faster. So this will become tan x plus tan 2x upon 1 minus tan x tan 2x. If I cross multiply, what I am going to get is tan of 3x minus tan x tan 2x tan 3x, and this will be equal to nothing but tan x plus tan 2x. Once we have done, you can see that the value of tan x into tan 2x into tan 3x can be obtained as nothing but tan 3x minus tan 2x minus tan x. This is important because we have again split it into addition and subtraction. Now in the next step we can integrate. So integration will become integration of tan 3x dx minus integration of tan 2x dx minus integration of tan x dx. The first one, integration will become log of sec 3x by 3. This will become log of sec 2x by 2. And the last one will become log of sec x. Now here important thing is there is a mod sign here. You can write a mod sign. So this is the answer to the question. Now in this 2019 question, we will again use the same idea. Primarily it is a question of trigonometry. So we will start with sine 5x by 2. By sine x by 2, simplify it and then integrate it. So in order to simplify, a simple thing can be done. We can multiply and divide by cos x by 2 and 2. So this cos x by 2 can be written above as well. And now once we have done that, what we can do is we can write the numerator as nothing but sine of this angle plus this angle that will become 3x. And the second part will become nothing but sine of this angle minus this angle, that will become 2x. And in the denominator, what we have got is nothing but sine x. Now, once you have this, the first part now can be written as nothing but 3 sine x minus 4 sine cube x. And this can be written as 2 sine x cos x. Divided by sine x, you can see that we have figured out a factor of sine x. It will get cancelled out. And in the next step, we have got something as 3 minus 4 sine square x plus 2 cos x. Now this part is fine. We will have to do, let us say, one more step. Let us not call it step 2. So now here this part, I can again write it in terms of cos. So this can be written as 1 minus cos 2x plus 2 cos x, which can eventually, and there is a 4 here. So if I write it down, this will become 3 minus 4 plus 4, this is 2. So this will become nothing but 2 plus 2 cos 2x plus 2 cos x. And now if I further simplify, this becomes 1 plus 2 cos x plus 2 cos 2x. Once we have this, we can integrate and get the answer. So in the next part, we will do integration. So this will integration of dx plus 2 times integration of cos x dx plus 2 times integration of cos 2x dx. The answer comes out to be x, 2 sin x and sin 2x plus c. So you can see that once we have done this much, our option C matches.
In this next problem type, we have been given sine of x minus a into sine of x minus b in the denominator. So the trick is, if both of them are same, then take sine in the numerator, and in this sine subtract both of these angles. So it will become x minus a minus x minus b. Now if you subtract them, as a result, what you will get is b minus a. And once you have that b minus a, we will divide that in the denominator. What is the advantage of doing this? See, now this 1 upon sine b minus a will go out. We can expand this as sine of x minus a into cos of x minus b minus cos of x minus a into sine x minus b divided by sine of x minus a into sine of x minus b dx, which eventually can be split into two different integrals. This will become sine of b minus a. First part, you can see that will become sine of x minus a into cos of x minus b by sine of x minus a into sine of x minus b. Here the first term will get cancelled out. And in the next part, we will have the same first part, that is sine of b minus a. But in this integral, what will happen is, we will get cos of x minus a into sine of x minus b divided by sine of x minus a into sine of x minus b. You can see that now the second part will get cancelled out. And once I do so, what am I getting? As a result, the first part reduces itself into, and we can take this 1 by sine b minus a out. And first integral is nothing but cot of x minus a dx. And the second will become cot of, first one is x minus b, second one is x minus. So both of this can be integrated because integration of cot x is nothing but ln sin x. So this will become sine of b minus a. This is ln of mod of sine x minus b minus ln of mod of sine x minus a plus c. If a similar kind of question is given where we have sine of
First term is sine, second one is cos. Here instead of sine, we'll multiply by cos of x minus a minus x minus b. So when you will d as a result, when you this subtract, this will become cos of b minus a. And what you have is sine of x minus a into x minus b in the denominator. And once I simplify this 1 by cos b minus a can be parked outside. This integral will become cos of x minus a cos of x minus b minus sine of x minus a into sine of x minus b divided by sine of cos of sine of x minus a into cos of x minus b. Now once we have this, we can split it into two integrals. So you can see that this is the original idea where we can split two integrals into standard integrals and get the answer. So if I split it up, then cos of x minus a into cos of x minus b would be divided by sine of x minus a into cos of x minus b, and as a result cos of x minus b will get cancelled out. And in the next part, what we will have is nothing but sine of x minus a sine of x minus b divided by sine of x minus a into cos of x minus b. Now we can see that the first term will get cancelled out, and as a result what we are getting is 1 upon cos of b minus a parked outside, and the first integral is nothing but cot of x minus a dx, and the next will become tan of x minus b dx. Now we can integrate this and get the answer. So my final answer becomes log of sine of mod minus of ln of sec of x minus b mod plus c. Of the type 12 integral, or the last integral based on trigonometric integrals, is one when we have a root of sine of x minus a by x minus b. So what we are going to do here is we are going to rationalize it. We have x minus a and we have sine of x plus a. So we are going to multiply what is in the numerator one more time. So you can see that I have multiplied and divided by x minus a. And as a result, what will happen? The numerator will become free. It will go out of the radical sign. And in the denominator, we have sine of x minus a. X plus a into sine of x minus a. Now in this, the first one can be expanded and written as nothing but sin x cos a minus cos x sin a by root of sin x plus a into x minus a dx. You can split it into two parts. The first part will become sin x cos a by root of sin x plus a into x minus a dx, then minus cos of x sin a by root of sin of x plus a into sin of x minus a. See, once we have this, now the life becomes easy, because in the first part, whatever is in the denominator, in the first integral, so let us call this as integral 1 and solve it separately. So this will become the first integral. This will become the second integral. So if I write the first one, it is sin x cos a. So I1 becomes nothing but integration of sin x cos a, and this sin a plus b x plus a minus x minus b can be written as cos square a minus cos square x dx. We have interpreted in this manner because now we can put cos x equal to t. That will become minus sin x dx is equal to dt. This integral will reduce itself into cos of a, which is a constant. We will have a minus sign, then dt, and you can see that this will become root of quadratic. So cos square a minus t square, a square. So this will become minus cos a into sine inverse x by a. X is nothing but cos a and by t, x by a, so t by cos a. So now you can put the value of t, that the value of t here is nothing but sin x, cos x, sorry. This will become sine inverse cos x by cos a. This is the first part of the solution. Once you have seen the first part, now the second part will become easier to implement. In the second part, I2, what we are going to do is, like we did in the first part, here we have cos x sin a. So we'll write this as nothing but sin square x minus sin square a. And now instead of cos x, we'll put now sin x as t. And I'm putting b. So this will become cos x dx equal to dv. And as a result, the integral that we are getting will become nothing but sin a, which is a constant. You have cos x dx. This can be replaced by dv directly. So let us write dv in its place. And denominator, what you are getting is v square minus sin square a. We have a direct formula for that. You can apply and get the answer. You can see that this technique of splitting it into two parts is very important. Now, the important idea is to get the numerator out of the radical sign. Now, in this case, if I want to do, I will again apply the same process and get the answer. So here, let us correct it. This is cos of. So we will multiply and divide by root of cos x minus a by root of cos x plus a. So I will not go deeper. This much is fine. You can solve after that. Now, the next category of problems is problems based on rational functions. In this, the first category, and not the type 22 problem, is based on even powers. So a question is given in which the powers are even. Let us look into this question. So what is the technique? Technique is very simple. You divide by x square numerator and denominator. So this will become 1 plus 1 by x square. And once you do it, this is x square plus 2 plus 1 by x square. Now the idea is that if there is a plus sign here, we will try and generate x minus 1 by x. So sign should be opposite. X minus 1 by x in the denominator. So what I can do is I can write this as nothing but x minus 1 by x whole square plus 2. So this will become plus 4 dx. Once we have done this, you can see that whatever is written here, the derivative is written here. So we can put in the next step x minus 1 by x is t. And it is important that the sign here should be opposite to the sign in the numerator. This is a very important point. Now once you do that, the derivative will become 1 plus 1 by x square dx is equal to dt. Now in the third step, when you have done this, we are going to write it down. So this becomes dt and it converts it into t square plus 4. That is 1 by quadratic form. The integral becomes 1 by a tan inverse x by a. So this will become t by 2 plus c. T here is nothing but x plus x minus 1 by x. So let us resubstitute and get the final answer. So this is x minus 1 by x by 2 plus c. Now if I look into this 2024 question, it can be simplified and converted into the earlier problem type. In the first step, now if I look into this question, I can write in terms of sine and cos. So this will become 1 by sine plus sine x divided by 1 by sine x into 1 by cos x plus sin x by cos x into sin square x dx. Once you have this, in the simplified manner, if I take LCM, this will become 1 plus sin square x. Now, you will also have a cos x here from denominator, and this becomes 1 plus sin raised to the power 4x. So just by doing one substitution, it will get converted into the earlier form. If I put sin x is equal to t, then cos x dx will be equal to dt. And once you have this, and if I substitute, this will become 1 plus t square by 1 plus t raised to the power 4, so all even powers. We have got it in the form that we wanted to. In the next step, I will divide by t square. This will become 1 plus 1 by t square dt. The denominator will become t square plus 1 by t square. I have little bit rearranged the term so that you can take into account. Since there is a positive sign in the numerator, what we are going to do is, we are going to write the denominator as nothing but t minus 1 by t whole square plus 2. Once you have done that, you can see that in the next step, in the third step, we can put t minus 1 by t as v. And if we differentiate, it becomes 1 plus 1 by t square dt is equal to dv. And if I put the values, it becomes nothing but integration of db by v square plus 2. As a result, I can write this as nothing but 1 by a, that is root 2, tan inverse of x by a, so v by root plus c. Now, in order to find the value of c, what they have done is, we have told us that if I tan x tends to pi by 2 from minus side, then the value of this becomes 0. So now we can see that as x tends to pi by 2, if x tends to pi by 2, let us say what will happen to v. So if x tends to pi by 2 minus, so t was nothing but sin x, so t will tend towards 1 minus. And if t becomes 1, now what will happen to v? Let us see that. So this will become 1 minus 1. Here v will tend towards 0. When v tend towards 0, the integral that we are looking at will also become 0. So what they are saying, the value is 0. This became 0 plus c. So from here we were able to get the value of c. C comes out to be. Now in the fourth part, what they are saying is, find the value of the function at pi by 4. Again, instead of doing substitution, we can again do the same thing. If x becomes pi by 4, now what will happen to the t? T will become nothing but 1 by root 2. Now if t becomes 1 by root 2, the value of v corresponding to that will become 1 by root 2 minus root 2. And this, if I take LCM, will become minus 1 by root 2. If I put the value in the integral, let us see what happens to the integral. The value of the integral becomes 1 by 2, 1 by root 2, tan inverse of minus 1 by 2. Let us see which option matches. So you can see clearly that D option matches. Now type 23 is algebraic twins. In case of algebraic twins, what you will observe is, the numerator part in the earlier question is missing. It is the same question, just the numerator part is missing. So what will happen is, when we will solve this, we will have to split it into two integrals that largely look out the same. So if I divide by x square, that process still remains same. This will become x square 5 plus 1 by x square dx. Now see, this you can't integrate because we have not got that 1 plus x square 1 minus x square. So if it is not there, we are going to generate it. So we are multiplying by 2. And this numerator now can be split into nothing but 1 plus 1 by x square minus 1 by 1 minus 1 by x square by x square plus 5 plus 1 by x square dx. Now once I have this, we can write it down as nothing but 1 plus 1 by x square dx by x square plus 1 by x square plus 5. And the second one can again be written as 1 minus 1 by x square dx by x square plus 1 by x square plus 5.
You can see that you got two similar looking integrals and they are known as twins.
Now what we will do, we will solve the first one separately, we will solve the second one separately, and then ultimately we are going to subtract and get the final answer. So if I want to find the integral 1 now, this is my first step, this is my second step. It is nothing but 1 plus 1 by x square. So now you can see that if we have 1 plus 1 by x square, we will try and generate the opposite sign in denominator. So this we can write as x minus 1 by x whole square. And as a result, there is going to be a minus 2, so we will have to add 2, so this will become 7. Now this question we have solved earlier. We can put x minus 1 by x is t and we can solve this part.
This is the exact same question that we solved earlier.
In the second part, or the third part of the question, we will solve I2. That is nothing but 1 minus 1 by x square. Now since there is minus sign in the numerator, we will write plus in the denominator. So x plus 1 by x whole square plus 3 dx. In this case, if I want to solve, I will put x plus 1 by x as v. And this will again become the question of previous type and it will get solved. You can see that since we are getting two integrals of similar type, it is known as algebraic twin. Now in this 2021 question, this idea of algebraic twin and rational polynomial that we looked into earlier is getting used. So what we can do in this question is, I can split it into two integrals. So it is not exactly algebraic twin, it is a combination of last two questions. Let us see how it works out. So in the first part, I can divide it by the denominator. So the first part will become x raised to the power 4, 3x square plus 1 into tan inverse of x square plus 1 by x dx. And the next part, if I try and split up, you can clearly see that tan inverse x is there. So tan inverse x wala part, this part will get cancelled out because in denominator also we have got the similar kind of part. So if I put the value, this is what I am getting. X raised to the power 4, 3x square plus 1 into tan inverse of x square plus 1 by x. You can see that this part will get cancelled out. And we have got two integrals. This is my first integral. This is my second integral. After simplification, we are getting two integrals. Now how to solve them? So in the next step, we will solve first the first one first. So first integral is nothing but x square minus 1 dx by x raised to the power 4 plus 3x square plus 1. So it looks more complicated than it actually is. This we can simplify and write as x plus 1 by x. And this gives us the idea that, okay, this can be reduced in x plus 1 by x wala form. So now once you have this, the idea is quite clear. Now we can write the numerator, we can also divide by x square. This is what we are going to get. This will become x square plus 3 plus 1 by x square. And the second part is self-explanatory. It will become tan inverse x plus 1 by x. So now see, there are 2-3 things. We can put x plus 1 by x as t. That is one way of thinking. But a better thing would be to put in terms of tan theta, because this also we want to remove. If I do this, it will become 1 minus 1 by x square. Dx is equal to sec square theta d theta. Let us see what happens if I simplify. So this part is gone. This is sec square theta d theta in the numerator. In the denominator, if you carefully observe, this will become nothing but square of this plus 1. So this will become tan square theta plus 1. Because if you square this, it is x square plus 1 by x square plus 2. There is plus 3. So 1 will left, rest of the thing will become tan square. And then this will become theta. You can see that 1 plus tan square theta is equal to sec square theta. So both of them will get cancelled out. And we are left with a very simple integral d theta by theta. That will become log of mod of theta plus c. The answer of the first part comes out to be tan inverse of log of tan inverse of x plus 1 by x plus c. Now let us move toward the
second part of the integral. Now you can see that in the third, we are getting the second part. So now if I want to do this part, I will have to write I2 as nothing but integral of dx by x raised to the power 4 3x square plus 1. So this is an algebraic twin now. So after solving this, you will also have to solve algebraic twin. So this is a lengthy question. This is not a small question in the exam. So once you have this, now this can be divided by x square. So 1 by x square will get 2, we will multiply and divide. So what we are getting from here is x square plus 3 plus 1 by x square dx. And then we will be able to split it into two integrals that are doable. So 1 by 2 is fine. This can be written as 1 plus 1 by x square. This is the first part. And the denominator, what is there, we can write it as x minus 1 by x whole square plus 2. So this will become plus 5. And then the next part will become nothing but integration of 1, and we have a minus sign in between. 1 by x square dx divide by, now we will put opposite sign, x plus 1 whole square. This will become plus 1. Now we can see that the next step should be to find the integral and then get the answer. So if I write the integral of the first part, it will be, you can see that this in the first part I have put 1 by x minus 1 by x is t, and the derivative is written here. So directly I am writing the integral as nothing but tan inverse 1 by root 5, 1 by a tan inverse x by a. So x minus 1 by x by root 5. And I am doing a little bit of shortcut because otherwise it will become a really lengthy problem. Next will become 1 by 2 tan inverse of x plus 1 by x by 1 plus c. You can see that you have got all the parts now. What they are saying is the answer that you have got, do comparison. In the first part where we got tan inverse of x plus 1 by x, whatever is the coefficient is alpha. So if I compare the coefficient here, there is no coefficient here. So alpha comes out to be 1. If I compare the second part, you can see that x square minus 1 by x. So this part is nothing but the second part. So whatever is outside, so beta will become nothing but 1 by 2 root 5. And gamma is whatever is inside. So gamma comes out to be nothing but 1 by root 5. Now if you have the next part, that is nothing but delta. It is nothing but the coefficient here, and that is nothing but minus 1 by 2. Now what they are asking towards the end is in value of expression 10 times alpha plus beta gamma plus delta. So 10 times alpha plus beta gamma. So beta gamma plus the beta gamma, if you multiply, this will become nothing but minus beta gamma will become 1 by 10 plus delta will become minus 1. So if I simplify this, this becomes 10, this becomes 1, this becomes minus 5. So answer of this question becomes nothing but 6. Now in type 4, we are going to look into, type 24, we are going to look into questions where we have to take x to the power n common. Now there are these three common forms in which the question would be asked. But an easier way to think is take x to the power n common, that is always easier to remember. If I look into this 2019 question, if I want to do this question, the trick in this question is to take certain powers of x common. You will have to do little bit of hit and trial once or twice, then you will be able to get. So if I take x square common from denominator, it becomes x square into x raised to the power minus 1 dx. In the next step, let us divide the numerator by this x square. So this becomes 2x minus x raised to the power minus 2. And now you can see that whatever is written in the denominator, if I take this as t, so if I take x raised to the x square plus x raised to the power minus 1 as t, the derivative of same thing is written in the numerator. So this integral reduces itself into dt by t, and the answer becomes log of mod of t plus c.
So the answer in this case will become log of mod of x square plus x raised to the power minus 1. Now let us see now which one matches. So you can see that your C option matches. Now this question is again based on similar kind of idea. What we can do here is I can take x raised to the power 6 outside. So 3 is already there. If I take 6, there is this power 2 by 3 that will get multiplied. Inside we will have x raised to the power minus 6 plus 1 raised to the power 2 by 3. What is the advantage of doing that? Because if you simplify this will become x raised to the power 7 into x raised to the power minus 6 plus 1 raised to the power 2 by 3, and we can take it above and we can write it like this. Now the next steps are very simple. We can write x raised to the power minus 6 plus 1 as nothing but t. So if I differentiate minus 6 x raised to the power minus 7 dx will be equal to dt. So if I want to write my answer, it can be got in the next step. So we have minus 1 by 6. This will become dt, and then we have t raised to the power 2 by 3. The integration becomes extremely simple. It will become t raised to the power minus 2 by 3 plus 1 by minus 2 by 3 plus 1 plus c. And ultimately, if you simplify, this is minus 1 by 6. And this part will become 1. This is 1 plus x raised to the power minus 6 raised to the power 1 by 3. We have 1 by 3 here. That will eventually cancel out. Numerator will become 1 by 2. And now we can take this x raised to the power 6 outside, because in the answer they want us to do so. So if I take it out, this will become x raised to the power 6 plus 1 raised to the power 1 by 3. This becomes x square. You can see that the function that is written, now they are saying it is x fx. So here x fx is nothing but minus 1 by 2 x square. So the value of fx, if I want to find, is nothing but minus 1 by 2 x cube. Let us check the options. You can see that B option matches. Now in this next question, what we are going to do is, we are going to take x raised to the power 7 common. So this will become 5x raised to the power 8. 7x raised to the power 6 by x raised to the power 14. Since we have taken common as 7, this will become minus 5. This will become minus 7. This will become 2 whole square. Now, why is this interesting? Because now this 14 can be taken above. This will become x raised to the power minus 6. This will become 7 x raised to the power minus 8 by x raised to the power minus 5. X raised to the power minus 7 plus 2. Now this is very interesting to observe that in the next step, what we can do is we can take this denominator and put it equal to t. The derivative will become 5x raised to the power minus 6 minus 7x raised to the power minus 8 dx is equal to dt. And my integral reduces itself into nothing but, you can see that a minus sign is missing, so let us put that. This becomes dt, this becomes t square. That is very simple to integrate. The answer will become nothing but 1 by t plus c. So answer to this integral is, t was nothing but x raised to the power minus 5 plus x raised to the power minus 7 plus 2 plus c. Now in order to get the value of constant, they have given the value when we put x equal to 0. When we put x equal to 0, the denominator will become infinity and hence the fraction will become 0. And they have given the value 0. So from this first condition, if I apply this was the first part. In the second part, if I apply the condition, c comes out to be 0. Once we have got c equal to 0, what they are saying is value of 1 you need to find. So f of 1 if I find, it is going to become 1 plus 1 plus 2. This is nothing but 1 by 4. So value of k comes out to be 4. Now this 2019 question tries and connects the idea of substitution with this current idea that we have done. So if just take the value of sin theta and put it equal to t.
the derivative of this will become cos theta d theta is equal to dt. And the current integral that is given to me in the next step reduces itself into t raised to the power n minus t raised to the power 1 by n, t raised to the power n plus 1 dt. Now why is this interesting? Because now I can take t raised to the power n outside. So this will become t 1 minus t raised to the power minus n plus 1. And now you can see that you have 1 by n here. This will be n plus 1. So one power will get cancelled out. And now if I put whatever is inside as t, the question will get solved. In the third part, we can put t raised to the power minus n. 1 minus this is equal to v. If I put it, it becomes minus of minus n plus 1. T raised to the power minus n dt is equal to dv. Let's just substitute. If I substitute, I have 1 upon n minus 1. The numerator will become nothing but v raised to the power 1 by n. And then whatever is there, rest of the thing, you can see that it is already present. So this will become nothing but dv. So once you have this, the integration becomes very simple. Integration becomes v raised to the power 1 by n plus 1 by 1 by n plus 1 plus c. If I resubstitute the values, you can see that the c option will match. Now if I move towards this last problem category, this last problem category is based on irrational integrals. Now let us look into the first category of problem in this. The first category is when you have a square root of a quadratic. So we had seen 1 by square root of quadratic, 1 by quadratic. Now we are talking about square root of quadratic. So there are these three set of formulas that we should remember. In this formula, important thing is when you are writing it, let us say for the first part, for this thing, x square plus a square, because it is somehow difficult to remember. We will write x by 2, then copy down the same term. This is a trick to remember it. Then we will copy a square with its sign. So there is plus a square divided by 2. And then write the derivative of its reciprocal. So that will become nothing but log of x plus root of x square plus a square plus c. Now it is always better to put modulus inside the log. Now that is the correct way of doing it. You can see that we can use this technique and find the other two results as well, which are not very difficult to remember now. If I look into this 2023 question says that you have been given integration of root of x plus 7 by x. And then a question is based on that idea. So in one step, what we can do is we can just substitute x as nothing but t square. If I do this, the answer to this question becomes very simple. Dx will be equal to nothing but 2t dt in the first part. And this integral reduces itself into root of t square plus 7 by t into 2t dt. T gets cancelled out and you have got the standard formula. So you can see that now this can be written as a square x square plus root 7 whole square. If I have this, we can apply the direct formula and get the answer. So answer becomes x by 2. So this will become t by 2. Copy down the same thing. T square plus 7. A square with sign. So 7 by 2. Then log of t plus root of t square plus 7 modulus plus c. Now you can see that here this 2 will get cancelled out. And finally we are going to get a very elegant result that looks like this. T root t square plus 7 a log of t plus root of t square plus 7 plus c. So once you have got this, now what they are saying is if I find the value of I9, so I9 value is given like this, and then I1 value they have given like this. They want us to find the value of alpha. So what I need to do is just put the value of t as nothing but 9 here. So let us first go back and find the value of t square and then do it. So we know that x was equal to nothing but t square.
So if Tx is equal to 9, correspondingly T will be nothing but 3. And so if I put T equal to 3, in this I should get my third step. So if I put, this will become 3. This will become 9 plus 7. Second part will become 7 times log of 3 plus root of 9 plus 7, that will become 16. So the answer comes out to be nothing but 3, and there is plus C also, into 4 plus 7 log of 3 plus 4, that will become 7 plus C. You can see that what we have been given is 12 plus log 7 log 7. So this is exactly same as the value of I9 that we are getting. So from here we can conclude C is equal to C. This is the first part. The fourth part, now they are saying is if I put x equal to 1, correspondingly the value of T will also become 1. And what I need to now find is the value of I1. So I just will put here 1. So this will become 1. This will become root of 8. Then there is 7. This will become 1 plus root of 8. And C we have figured out came out to be C. So now if I look into this, you can see that what is given to us is on the similar line. And so this part matches, this part matches. So alpha correspondingly will become root of 8. What they are asking us is the root value of alpha raised to the power 4. Alpha raised to the power 4 will become 64. Now this 26 problem type is based on the idea where we have linear by root of quadratic or linear by quadratic expression. So the method is very simple. The linear in the numerator can be written as nothing but a times derivative of quadratic in the denominator plus another constant b. This is the logic we are going to use in order to split this into two integrals that can be solved and get the answer. Now let us look into this question that is given to us. So this 2x plus 6 can be written as a times derivative of quadratic that is written below. So 3x square plus x plus 1 plus b. So if I write it down, this becomes a times 6x plus 1 plus b. If I compare the coefficients, you can see that this will become 6a into x plus a plus b. If I compare the coefficient, the value of 6a will be equal to 2. A comes out to be 1 by 3. And correspondingly, a plus b is equal to 6. Here b comes out to be 6 minus a. 6 minus 1 by 3. That is 17 by 3. So in the first step, once you have got this, in the second, we will use this idea to split it into two parts. You can see that we will have a times this derivative, that is nothing but 6x plus 1, divided by root of 3x square plus x plus 1 dx, and then b into integration by root of 3x square plus x plus 1 dx. We know the value of a and b. Let us put it. So a is nothing but 1 by 3. And the first integration is 6x plus 1 by root of 3x square plus x plus 1. The next is nothing but 17 by 3. And this is root of 3x square plus x plus 1. Now we can see that this is converted into a form that can be done. So this is my integral 1. This is my integral 2. We'll find them separately and then resubstitute the value in the step 3. So if I want to find integral 1, it is 6x plus 1 by root of 3x square plus x plus 1 dx. So we can take 3x square plus x plus 1 equal to t. Differentiation becomes 6x plus 1 dx is equal to dt. And if I substitute the value of the integral becomes dt by root of t. And it becomes very simple, t raised to the power 1 by 2 by 1 by 2 plus. It was very easy to figure out the first part. And now in the second part, you can see that if I want to find integral 2, the third part, it was nothing but 1 by root of 3x square plus x plus 1. We can generate a perfect square. This is 1 by root of quadratic standard form. So in order to do that, you will have to take root 3 common. Let us park it outside. and this will become x square plus x by 3 plus 1 by 3. Now if I generate a perfect square, and this is one skill set that everybody should know, this is 2, and you can do it really fast if you use this shortcut. Whatever is written here, take half of that will become 1 by 6, add 2x, square it, and subtract the square of that. So 1 by 36 plus 1 by 3. So like this, if you do, you will be able to get an answer. Now once we have done this, and you can clearly see, let us simplify and then write it down. So 1 by root 3, this is dx by, and now if you simplify this, this will become x plus 1 by 6 whole square. This will be 12, this will become 11 by 36. So now you have got a standard integral. You can apply the formula and get the answer. So let us do that also. So the formula for integration of 1 by x square plus a square is nothing but 1 by a tan inverse x by a, and from there we will be able to get the answer. So the answer, actually there is also a root sign. So let us also put a root here, then the formula would change. We can't apply this formula. It would be nothing but log of x plus root of x square plus a square. So let us apply this formula and get the final answer. So 1 by root 3 was already there. Log of x, in place of x, x plus 1 by 6 is written, plus root of x plus 1 by 6 whole square plus 11 by 36. You can see that we have got the answer for both the parts. We'll substitute here and get the final answer. So this is the technique, and this is a very interesting technique to solve a lot of questions. Now let us go into type 27, that is irrational functions of the form 1 by x root y. See here, x is also a polynomial, y is also a polynomial, but there are 4 cases that we look into. When x becomes linear, y becomes linear, quadratic linear, linear quadratic, quadratic quadratic. The interesting thing is to observe y here, because that is going to fix a lot of things. If y is linear, the very simple thing would be to put that linear as nothing but t square or z square. This is the first part. When it becomes a quadratic, in the last 2 cases, you can see that if linear, it is profitable to put 1 by x as t. And in the second case, it is interesting to put y by x as nothing but t square. Now let us see how it works out in terms of question. There is this 2019 question. So in order to solve this question, we will put 2 minus x plus 1 as nothing but t square, as I told you earlier. So 2 times dx will be equal to 2 dt. T will get ultimately cancelled out. The integral reduces itself into the value of x can be t square plus 1 by 2. So we are substituting the value of x in the numerator. There will be t dt, and 1 t we will get from the denominator. So this t will get cancelled out. Now if I simplify this, what am I getting? I am getting t square by 2 plus 3 by 2 dt. So if I integrate this, 1 by 2 integration of t square dt will come, plus 3 by 2 integration of dt will come. So answer becomes 1 by 2 t cube by 3, 3 by 2 t plus c. This is the answer that we are getting. So now what they're saying is simplify it. So let us rewrite and simplify it. In the third step, if I rewrite, this will become nothing but t cube. So t cube will be nothing but 2x minus 1 raised to the power 3 by 2 by 6. Then we have 3 by 2t, that is 2x minus 1 raised to the power 1 by 2 plus. So if I take 2x minus 1 raised to the power 1 by 2 common, because it is, they have asked us to take it so. So what will be left? We will have 2x minus 1 by 6 plus 3 by 2, and this becomes nothing but my fx. So if I simplify, and then let us see what do I get. So my fx comes out to be nothing but 2x minus 1, and if I multiply here 3, this will become 9, and what we'll have is 6 in the denominator. So answer comes out to be 2x plus 8 by 6, or x plus 4 by 3. That is option B comes out to be the correct answer. Now in this next 2023 question, you can clearly see that it is 1 by quadratic root quadratic form, and we have discussed this, that there are 2 substitutions that might work. One is nothing but that we discussed earlier was when we put 1 by x. X is nothing but the outer one as t and then y by x as t. So what this technically means is, if you have this question, we can put 3 plus 4x square is nothing but 1 by t. Same thing. We can, or y by x, that is 4 minus 3x square by 3 plus 4x square as nothing but t. So these are two ways of doing this question using which you can solve this. But I am going to use a third method which is much more simpler in this scenario to do trigonometric substitution. So what you can do is, we can put x as nothing but 2 by root 3 sine theta. It would be better if I put cos theta, you will understand why in a minute. If I do so, what you will get from here is nothing but dx is equal to 2 by root 3 minus of sine theta d theta. So in the second part, if I want to do it, my integral comes out to be minus 2 by root 3 sine theta d theta. And then if you substitute the value of x there, this is 3 plus 4 into 4 by 3 cos square theta. And the next part, if you simplify, this becomes root of 4 minus 3 into 4 by 3 cos square theta. And if I simplify this, it becomes minus 1 by root 3 sine theta d theta divided by, and this 3 we can take outside, so this will become 1 by 3, this will become 9, this will become 16 cos square theta, this comes out to be sine theta into 2, and you can see that this portion from here will now get cancelled. 2 is also there, it will also get cancelled. Now once you have this and this much control if you have developed, the next step, third step, would be to further simplify it. So in the next step, you can see that you had 1, this 3 will get above and will become root 3. We have d theta, and it reduces into one of our standard forms, 19 plus 16 cos square theta. Now this is a trigonometry form that we have done earlier. We'll divide by cos square theta in numerator and denominator. So this becomes sec square theta d theta. This will become 9 sec square theta plus 16. Which in turn, if I simplify, becomes minus root 3 sec square theta d theta. This I can write as 1 plus tan square theta. So this will become 9 tan square theta. 9 plus 16 will become 25. Now what I can do is, in order to simplify it further, I can take 9 outside. And now what we have is sec square theta d theta by tan square theta plus 25. In one step we can get the answer. So you can see that if I just put now tan theta is equal to t, it will get solved. So what we have is 1 by 3 root 3. This I can write as 3 root 3. And the rest of the thing, this will become dt. This is t square plus 5 by 3 whole square. So we get our answer. Our answer comes out to be 1 by a. A would be 5 by 3 into tan inverse of t by 5 by 3 plus c. Now once we have figured that out, the question says that f of 0 is equal to 0. So if I put x equal to 0, let us see what will, if I put 0 here, you can see that theta will become pi by 2. Theta will become pi by 2, and corresponding to pi by 2, t will tend towards infinity. So if t tend towards infinity, what will happen to this term? So now the value, and when this happens, is given as 0. But if I look into this, this is minus. 1 by 5 root 3. This will become nothing but pi by 2. And then we have c. The value of c we can get from here. It is pi by 10 root 3. Now once you have got the value of c, let us write the value of c. Now from here, what they want is the value of this function when I put 1. So let us see what happens if I put 1. So if I put 1 in the function, when we put x equal to 1 here, what you can observe is cos theta becomes root 3 by 2. So theta in that scenario will become pi by 6. And if I put theta is equal to pi by 6 in this step, the value of t correspondingly will come out to be 1 by root 3. So once I have got the value of t, I can put it in the question that is given to me. So now if I put it up, now let us see what do we get. So t is equal to 1 by root 3. So what I had was 1 by 5 root 3. And then here if I put 1 by root 3, this will become root 3 by 5. And then the value of c is also given to us. Now that we figured out was nothing but pi by 10 root 3. And this value, if I check out, is given to me as nothing but 1 by alpha beta tan inverse beta by alpha. If I simplify this value, what is going to happen is we are going to get the value of alpha is nothing but 5 after solving. And the value beta will come out to be root 3. And if I figure out the value of alpha square plus beta, it will become nothing but 28. Now in type 28, we have questions that look like this: x raised to the power m into a plus b raised to the power n raised to the power p dx. Now in this question, the crucial idea, there are lots of shortcuts around it, but the crucial idea is to remove all the radical signs. So what I would need to do is put x in such a manner that all these roots get removed. So I can put x as t square here. And once I do so, this will become dx is equal to 2t dt. This will become t. This will become 2 plus t whole square 2t dt. If I simplify this, 2 will get outside. We have nothing but t square plus 4t plus 4 into t square dt. And if I simplify it, it becomes t raised to the power 4 plus 4t cube plus 4t square dt. And if I split it up, it is t raised to the power 4 dt plus 8 times t cube dt plus 8 times integration of t square dt. My final answer comes out to be 2 into t raised to the power 5 by 5. 8 into t raised to the power 4 by 4 plus again 8 into t raised to the power 3 by 3 plus c. And now the value of t we can put as root x and get the final answer. This becomes 2 by 5 x raised to the power 5 by 2. This is 2 times x square. This is 8 by 3 times x raised to the power 3 by 2 plus c. Now this 2021 is a very unique question. In this question, what you will have to do is generate a term. So what is happening is you have been given x minus 1 raised to the power 3 by 4 and x plus 2 raised to the power 5 by 4. So what I can do here is I can multiply and divide by x minus 1 raised to the power 5 by 4. So this will become 2 x plus 2 raised to the power 5 by 4, and here we can write x minus 1 raised to the power 5 by 4. What is the benefit of doing this? See, benefit of doing this is we have got a term 1 upon x minus 1 whole square. There is a dx. There is a dx. Dx divided by x plus 2 by x minus 1 raised to the power 5 by 4. This is the first step. In next step, in such kind of questions, I will put x plus 2 by x minus 1 is nothing but t. If I differentiate the first part, it becomes 1. If I differentiate the next part, it becomes 1 into x plus 2 divided by x minus 1 whole square. Dx is equal to dt. If I simplify the numerator part, answer will become minus 3 by x minus whole square is equal to dt. Once I have done this in the second part, in the third, we will be able to substitute the value and get a very good answer. So this will become minus 1 by 3. We have dt. And in denominator, what we have is t raised to the power 5 by 4. So answer to this question comes out to be minus 1 by 3. T raised to the power minus 5 by 4 plus 1. So minus 1 by 4 by minus 1 by 4. If I simplify, what I will get is 4 by 3. If I simplify this will become nothing but 4 by 3. The value of t is nothing but x plus 2 by x minus 1 raised to the power minus 1 by 4. So you can see that the C option matches. If I look into this 2024 problem, it is based on a very interesting idea. Like we did in the previous question, we can generate or remove this, rewrite this as x minus 1 raised to the power 4 by 5, x plus 3 raised to the power 6 by 5. Now once you have this, we will generate 1 upon x minus, we can multiply and divide by 6 by 5. So this will become 10 by 5, that will become 2. And x plus 3 by x minus 1 raised to the power 6 by 5. This is same as what we did in the earlier question. Once I do this, in the next part, I can put x plus 3 by x minus 1 as nothing but t. To differentiate the numerator, it becomes nothing but 1 into x minus 1 minus 1 into x plus 3 by x minus 1 whole square dx is equal to dt, which if simplified will become minus 4 dx by x minus 1 whole square is equal to dt. Once we have done that, in the next step, let us see what we can do. In the next step, we can write this as nothing but dt. Now, you can see that since you have differentiated in such a manner, what we will have is nothing but minus 1 by 4. And as a result, what we have got in the denominator is nothing but t raised to the power 6 by 5, which in turn will become minus 1 by 4. T raised to the power minus 6 by 5 plus 1 by minus 6 by 5 plus 1 plus c, and in turn can be written as minus 1 by 4 t raised to the power minus 1 by 5 by minus 1 by 5 plus c, and this will become nothing but 5 by 4 t raised to the power minus 1 by 5. Now what is the value of t here? Let us figure that out. So value of t is nothing but x plus 1, x plus 3. So it will get flipped. This will become x minus 1. This will become x plus 3 raised to the power 1. If I look into what they are trying to ask, they are saying that there is some constant that is a. So the value of a, if you observe, will become nothing but 5 by 4. And the power is nothing but b. The value of b becomes nothing but 1 by 5. If you have got the value of a and b, what they are asking is alpha, and acha also there is an alpha and beta, yes. Alpha is nothing but the coefficient of x in the numerator, so it becomes 1. Beta is nothing but the same in the denominator, so beta is nothing but also 1. Once you have got this value, what they are asking is alpha plus beta plus 20 AB. So if I figure out this value, alpha plus beta, that will become 2. 20 times AB will become 5 by 20. This will become nothing but 7. The answer to this question comes out to be 7.
If you like this video, you will also like PracBee's unique one-on-one last mile journey program. In this program, we sit with the student, understand their preparation till this point of time. And based on that, in step 2, we write a customized planner just for you to help you optimize your marks in JEE Mains exam based on whatever preparation you have done. In the step 3, we sit with you one-on-one by a set of faculties aligned by PracBee and help you implement the customized plan that we wrote for you. Students have come to us with limited, no or good preparation and all have been able to score their marks to a large extent. Ashish, using this program, was able to improve his fortunes by lot, starting from 95 percentile in JEE Mains attempt 2 to getting selected for mechanical in IIT Madras. Ditya, over a period of time, was able to crack into JEE Advanced using this program. If you think that this seems interesting to you, click on the link below in the description, fill the required details and somebody from my team will get in touch with you.